and gentlemen, from now on, we will officially start the International AAM Technical Meeting hosted by the Ministry of Land and Infrastructure and Transport of Korea and organized by the Korea Institute of Aviation Safety Technology. I am Yoon Bum-soo of the KIAST. I'll be your MC for today. Hello everyone, I am a co-MC announcer Yoon Hee-jung. Nice to meet you all. Simultaneous interpretation will be provided for today's conference. Please select channel 1 for Korean and channel 2 for English. For those of you who are here with us, you have received receivers. For today's conference will be broadcast online. For Korean, you can join us via the official YouTube channel of the KIAST. For English, you can join us via the UAM Team Korea's YouTube channel. Also, you can leave your questions in the comment section on Eventus or YouTube platforms while speakers deliver their presentations. I'd like to ask for your active participation. This 3-day conference will serve as a venue to share insights and ideas about AAM policies and technologies at home and abroad, and to explore the future direction for the development of the domestic AAM industry. Before we start, I'd like to briefly introduce daily programs for the next 3 days. On day 1, we will talk about the status of UAM policies and technologies at home and abroad, as well as UAM R&D demonstration and projects. On day 2, we will touch upon UAM certification and standardization and trends in the industry. On day 3, which is the last day, we will hold a workshop to set a direction for projects to help vehicle developers receive certification to further develop the aviation manufacturing industry. So I'd like to welcome all the participants, both offline and online. Each presentation will be followed by a Q&A session, so I'd like to ask for your active participation. Without further ado, we'd like to start today's meeting.
This event is conducted in strict compliance with COVID-19 according to the government guidelines. As I have explained earlier, this event will be held both offline and online. Despite their busy schedule, we have around 120 offline participants, and we also have 330 people from Korea joining us virtually, and also 60 others from Japan, Taiwan, and US to join us this occasion online once again. So thank you for your great interest. So let me introduce our distinguished guests. So I will name them one by one. So please welcome them your applause. Najin Hang, Future Drone Traffic Officer from MOLIT. Lee Dae-sung, President of KIAST.
항공우주시스템공학회
박정선, President of Society for Aerospace System Engineering.
육군 드론봇 발전센터 박원수,
Drone Bot Development Center of Republic of Korea Army. Last but not least, we have Song Seok-ham, Group Leader of SK Telecom. We also have many other distinguished guests from various organizations, but due to the time constraint, I think we have to move on. So we will begin this meaningful occasion with the opening speech by Lee Dae-sung, President of KIAST.
Please welcome him with a big round of applause.
여러분,
Distinguished guests, ladies and gentlemen, good morning. I'm Lee Dae-sung, President of the KIAST. First and foremost, I am delighted to host the International AAM Technology Conference to share and exchange top-notch technology and knowledge with global experts at home and abroad under the theme of advanced air mobility. Taking this opportunity, I'd like to express my deepest gratitude to all of you for taking part in today's meeting, both online and offline, despite the challenges posed by the pandemic.
특별히
My special thanks go to Director Na Jin-hang of the Ministry of Land Infrastructure and Transport for joining us today despite your busy schedule and dedicating yourself to the development of AAM in Korea. Also, President Park Jong-hyun of the Aviation Association, thank you so much for being here with us. On behalf of the KIAST, I'd like to also thank distinguished speakers and guests from the Civil Aviation Administration of China, overseas government organizations including Singapore, and international standard organizations such as ASTM International, as well as academia, research institutes, and the industry across the country.
오늘 행사는
For today's event, we have invited various experts from government organizations, research institutes, and related industries at home and abroad to discuss key issues such as main policies, technologies, and certification methods regarding the commercialization of AAM, which will soon fly over the urban areas in our cities.
여러분들도 잘
As you know,
아시는 바와 같이 미래 도심 항공
safety is considered the key to the success of UAM.
안전입니다. 이런 안전의 성공
It is essential to promote the linkage between every component of the UAM infrastructures and systems, including aerial vehicles, operation, controls, vertiports, and corridor selection and operation.
유기적으로 연계되어야 하고 우리가 목표라는
Securing safety in all these components is a must to meet our goal to commercialize UAM in 2030s. Against this backdrop, it is timely to hold this international technical meeting on AAM to exchange ideas about the future of UAM. Your insights and suggestions will be extremely helpful to promote better safety in the field of AAM.
매우 중요합니다. 참석하신 모든
I hope today's event will serve as an invaluable venue to share in-depth ideas to explore the future direction of technical and policy development of AAM among all participants to be reflected in national policies. Since this conference is held both online and offline, it will provide a fruitful opportunity to share global AAM policies and technologies, especially in Asia Pacific. Today is only the start of close exchanges and cooperation among several Asian countries to build a mutually beneficial collaborative network for AAM. On our part, KIAST is committed to making all necessary preparations to operate AAM as a dedicated organization in charge of aviation safety in Korea. Moreover, we will take the lead in supporting government policies to commercialize the new modes and system of transportation and cooperate with partner organizations to ensure the safe UAM operation in the future. Once again, thank you so much for joining us on site and online despite the pandemic situation. Also, I'd like to thank all our wonderful speakers for being here to share your expertise, and also all staff for making today's event possible. Thank you.
네, 말씀 감사합니다.
Thank you for your wonderful speech.
항공 모빌리티 상용화에 대한 국제적인 논의의 장.
This event will serve as a venue to discuss the commercialization of AAM.
이대성 원장님께
So
박수
please give him
부탁드리겠습니다.
another round of big applause.
네, 계속해서 오늘 행사를
Now,
공유해 주시기 위해서 함께 해 주신
Let's hear the welcoming speech by Najina, Future Drone Traffic Officer from MOLIT. Please welcome him with a big round of applause.
네, 여러분 반갑습니다.
Good morning, everyone. Nice to meet you all. I am Najina, Future Drone Traffic Officer from Ministry of Land Infrastructure and Transport. I'd like to extend my warm welcome to everyone who joined this conference to discuss the future direction of AAM and exchange your insights and ideas. What makes this occasion more meaningful is that we have people working hard for the development of AAM, not just from Korea, but also from other countries in Americas, Asia, and Europe. So welcome you all once again, and thank you very much. Also, I'd like to extend my gratitude to President Lee Dae-sung and others from KIAST for preparing this wonderful occasion and striving for the development of the aviation industry. As you understand, the aviation industry has been witnessing the second wave of advancement. Drones have started as a military tool, but with the development of drones of different sizes and forms, their applications have grown quickly too. To dominate this multi-trillion-dollar market, many countries are competing against each other, and the South Korean government keeps up with such changes as well. So phase 1 of the UTM R&D project will be completed this year to increase utilization of drones, and now we're planning for phase 2.
로드맵을 저희들이 제시를 했고요.
We have also proposed a roadmap for UAM in line with the Grand Challenge, and we are targeting the commercialization in 2025. And the Grand Challenge project is a demonstration project. We're also planning R&D across all areas from the vehicle infrastructure to traffic management. Uncertainty of the new industry will be removed, and the enhancement of a new bill to vitalize the industry is also in preparation. But we are bound to face a lot of uncertainties as we go down the road no one has taken yet. We have developed new technologies, institutions, and standards. Many organizations and experts are joining forces. Still, there are challenges. And I think you feel the same here today. Today's occasion, here, those who are on the challenging journey have come together. Simply sharing your agonies and experiences and discussing solutions will be greatly helpful to each other. After today, I hope we have more opportunities like this to convene together. And I don't think this is something that can be achieved by us alone, not just by Korea, but by all of us. As we work together, uncertainty will become clarity, moving up the arrival of a brighter future. Lastly, I'd like to inform you that I think we have 3 days left. This Thursday, KUAM Grand Challenge will have a business presentation. I'd like to ask for your active participation. Since we make this together, someday we'll be able to find a solution and step into a brighter future. Thank you very much. Thank you for the great words. So if you want to travel far, you have to go together. Since the UAM is a new territory, so I think we need new institutions and regulations. So let's move on.
네, 그럼 본격적으로
Without further ado, let us start presentation sessions, each of which will be followed by Q&A session. For the first session, I'd like to invite experts from key countries across the Asia-Pacific region, Korea, China, and Singapore, to start their presentations on government's efforts and plans to facilitate UAM operation. Our first speaker is Mr. Jun Park of the MOLIT. He will give a presentation under the title, A New Mode of Transportation, Urban Air Mobility KUAM Policy. Please give a warm welcome to Mr. Jun Park.
네, 안녕하십니까. 오늘 뜻깊은
Ladies and gentlemen, hello. I'm honored to be here with you, and thank you so much for joining us, both online and offline. My name is Jun Park. I'm from MOLIT. I'd like to talk about the government's efforts, including its policies and strategies. Well, we have started our big journey from UAM a few years ago, so I believe this event will be a very meaningful venue. So my presentation will help set the direction and lay the framework for the UAM industry. So the title of my presentation today is KUAM policy. I'll cover introduction, KUAM roadmap, UAM Team Korea, KUAM concept of operations 1.0, and K drone system. So this is what a metropolitan city looks like. As you know, we have the very high, very congested traffic, and with a lot of complex subway lines, which all contribute to the environmental pollution.
어떻게 해소할 수 있을까?
So how can we deal with the situation?
새로운 공항이나 헬리패드를 한번
Maybe
지어보면 어떨까요?
how about we build new airport or heliport near your home? During the construction, it will create all the noise and all the environmental pollutions. And even if it's built, you will hear all the noise from the flight.
무언가 있을까?
So how can we avoid all these but introduce a new mode of transportation? That is the UAM. So Hyundai, Hanwha, Sungbi, and Unist
기체를 개발할
have joined their effort to develop a clean and noiseless and eco-friendly aerial vehicle. So the Korean government has a keen interest in this development of a new mode of transportation. And as you know, we have strength. Korea has big strength in communication technology and automobiles and related parts.
벡터드 트러스트
So
기록하면서
the vector thrust, the rotor tilt, and there is another type, lift and cruise, and multi-copter method
배터리를 활용해서
are
있습니다.
the things that are enabled by the motor and battery technologies. So in order to have this UAM as a new mode of transportation, it needs to have a transportation functions, and we need to take consideration,
마련이 필요하게 되고
and we need to build a new ecosystem for UAM operation, including the vertiports. So the UAM is has been a new concept to Korea, the Korean government, back in around 2019. So in June 2020, the Korean government has released the KUAM roadmap, and since 2020, so under this roadmap, it specifies the government's effort from 2020 to 2035. So, and there are some technologies that are required to make that possible. As you know, including the core technologies and what kind of core technologies should be localized. That's why the Korean government has published the technology roadmap in March 2021. So UAM is a completely new type of transportation mode. So we needed a completely new manual and roadmap. So that roadmap is the concept of Operation 1.0 that has been published last year in September. The reason why we have attached 1.0 for this concept of operation is because maybe sometime later we might need to revise that to 2.0. So we plan to test and modify this ConOps. So the national governments all over the world are establishing UAM ecosystems, and they are keen in this part, and they are actively involved in various kinds of demonstration and R&D activities, including Korea. And we also have this KUAM Grand Challenge, and we have a big demonstration project, and we needed to go through the pre-feasibility test. We had a challenge last year in order to make this more make this plan more feasible. We have invited various kinds of related departments and stakeholders to be involved. So our goal is to start the commercialization in 2025, and this is a roadmap, and our final goal is to popularize the UAM by 2035. this is the schedule for our roadmap. As I've said, UAM is a completely new mode of transportation that hasn't been around before. So
지루함을 느끼실 수 있습니다. 그래서 저희는
it will take long. So during the process, we are also planning various kind of events to increase the public acceptance.
어느 구간에서 어느
And
구간까지 상용화입니다. 즉
I'm talking about commercialization.
단계를 거치게 될 거고요.
So when it is commercialized, people need to pay fees to take this UAM vehicle.
당연히 승객들도 늘어나게 될 것이고
And it might take some time, but as over time, the passengers for UAM vehicles will increase. So by around 2030, when it is completely commercialized and popularized, the usage fee will drop down, which will also attract further passengers.
그러기 위해서는 6가지의
So to make this possible, we have 6 strategies. The first strategy is, as you know, if we do not have any system put in place, we cannot attract operators. So that is why our strategy 1 is setting up regulation basis for safety. And also based on this foundation and framework,
어떤 기존 산업에서 이
the
신산업으로
operators in the private sector can make this a new sector from which they can earn profit. So our second strategy is strengthening private sector. And to do that, we need to set the route, explore routes that can make profit. So this is our demonstration route. It connects the Incheon Airport and Gimpo Airport, which are 2 airports in the metropolitan city, which can create better profit.
많은 지원과 협조를 해주신
So related to set this demonstration route, a lot of related government
진행을 해보신 분
organizations has been involved.
한번 그려 보여주셨는데요.
And their seasoned pilots have also joined in to draw this route. And the third strategy is steps for public acceptance. No matter how hard government makes its effort to make this possible, if we don't have passengers or users to use this service, it will fail. So that is why increasing public acceptance is really important in the process. But before having this UAM vehicle to be very popular, let's just imagine when there's a fire in a high-rise building. Then, to combat this fire, to fight this fire, there's a UAM vehicle that suddenly appears to catch this fire. Then people's acceptance will be increased.
이 새로운 교통수단이 UAM에서 군인들이
And also,
굉장히
we can also have this UAM for the military actions, which will also help people to increase their acceptance to the introduction of the UAM.
멀티
And this is also connected to our next strategy, which is the fourth strategy. This is creating infrastructure and connectivity. We need infrastructure that's suitable to the different size of the UAMs, including the small UAVs, to the large ones, including as well as vertiports.
2월 17일 그랜드 챌린지
In June 17, we will have a special explanation session for the KUAM Grand Challenge. More details will be provided in that event. And the strategy 5 is about industrial ecosystem.
그다음에 우리와의 계획이 아니라
Cooperation in the close cooperation among all the players in the industry is important. And the next strategy, which is the last one, is international cooperation. It is also essential to have this cooperation with international organizations.
우리의 활동 사항들을 약 2분 정도로 담아봤습니다. 영상을
And let us watch this about 2-minute video about our program.
네, 본 영상에서
So from this video clip shows that this UAM
우리 소비자들이 이용자들이 어떤 부분을 UAM을 통해서
it
멀티모달로서
describes
캐치해내는
the UAM operations, and it also talks about the multimodal system that is needed by the passengers. So let me give you one example. A passenger at the Incheon airport suddenly realizes that she forgot to bring her passport, and she calls her mom at home
여권 배송 시스템 신청해놨어.
and tells her mom that she called to the air drone to be sent to her house to pick up her passport back to the airport. So to her, there's nothing to worry. So this is a completely new mode of transportation that can solve a lot of our problems that we might face in our daily lives. So this is an advanced mode of transportation.
같이 노력해 주시면 감사하겠고요.
So taking this opportunity, I'd like to ask all of you for your kind interest in this project. So to make this possible,
2025년이나
as I've said, around 2025 or 2035, we will be able to see this UAM vehicles flying over our cities. We expect that around 100,000 people will use these vehicles. So we also looked at what kind of technologies that we need. So by around 2025, we will need about 4 vertiports. By 2030, we will need 24 vertiports, and by 2035, we will need around 52 vertiports. And as for
장표를 보시면 아무래도
the operators,
보니까
well,
이 정도의
at the initial stage, they will need a significant amount of investment. But by 2035,
발생할 수 있는 사업이니까요. 이런 부분에 대해서도 좀 많은
they will be able to make profit.
그러기 위해서는
in this sector. So I have already introduced you 6 strategies for KUAM. And to push that forward, I have listed 5 strategies for this project. So first one is about the safety. Safety is the key to the success for the UAM service. And second is gaining acceptance from people. And third is cost. It needs to be cost effective. And fourth, it needs to be sustainable because it needs to be around for a long period of time. And fifth is mutual development and cooperation between private and public. So this might seem a little complex. We need advanced technologies for that to make this possible. We need batteries. When charging, it can get really hot. So we need advanced technologies to deal with that, and we need all the related advanced technologies and top-notch technologies for flight services. And our ultimate goal is autonomous operation for UAM. So for about next 9 to 10 years, we will conduct and push forward this project. And our total budget is around 1.6 trillion. Well, today's event is organized by both by UAM Team Korea as well as the MOLIT of Korea. We are closely cooperating with each other to push forward this project. And we are also holding annual working level meetings amongst us. And so, as I've said, we will be hosting the Grand Challenge, and we are having a lot of collaborations to host this kind of event. And also, we are sharing common field of interest of participating organizations. And we are also collaborating to create a UAM special laws. And we are also collaborating with many related private sector companies, including Hyundai, Hanwha, Korean Air, SK Telecoms. And also, there are key players from academia, including Seoul University, KIAST, and others, government ministries, local governments, and related organizations, research institutes. And initially, this UAM Team Korea started with 37 parties, but within 1 year, it has jumped to 47 participants, and more will come to join our team. And so today we have given you a copy of KUAM ConOps 1.0 as a hard copy. So please take a look at it if you do have any free time after this conference. So this is a PSU is important, and vertiport operator is in green, which is also important and a key player. And the SDSP, PSU, vertiport operator, other stakeholders, ATC, and UAM air operators are all collaborating closely. And there are telecom communications that are closely cooperating as well. UHF, VHF are existing communication channels that made us communicate information with each other. But we will also make it possible to share other related information. But UAM, those are existing communication technologies that are used for the communication of existing aircraft. But as you know, UAM is a completely new mode of vehicle transportation, which is small. So we need suitable technologies to facilitate communication for the operation of UAM. And this UAM CONOPS 1.0 features background definitions, development direction of KUAM operation, KUAM CONOPS details at the initial phase, and its operation scenarios. So in this slide, it shows all the stages from planning, pre-flight, takeoff, ascending cruise, approach and landing, ground movement, post-flight. And this is a diagram that has been released back in September last year. As you know,
6만 피트까지 정부 항공교통 관제 기관에서
so the existing government organizations and the air traffic controlling office are controlling the operation of the flights that are flying up to 60,000 feet. But this is UAM it will be using different corridors, and PSU is a provider of service of UAM, and UAM and UTM service provider, and PSU. Take a look at the PSU. Take a look at the blue and yellow corridors. So this is kind of a overall diagram, a simplified diagram of how our skies will be arranged for the operation of existing aircrafts and the smaller aircrafts, such as UAM. And that's Data Exchange Protocol, or DEP, to facilitate the exchange of information between operators. And so if there's any changes or any kind of challenges when a UAM vehicle is flying over the city, then information and data will be communicated to it through advanced technologies.
그래서 이 운영 개념은
So this UAM CONOPS 1.0 will lay the foundation for the related law that's to be established in the future. And as I have already been explained to you, UAM Grand Challenge will help test and modify this CONOPS. And let's talk about automobiles. When there were first automobiles introduced, a lot of technologies were newly developed over time. The same can be said to the drones. So let us turn our eyes to the K drone system. So you see this line, red dotted line in this diagram. This marks the 150 kilometers, 150 meters or 500 feet from the ground. This is how high a drone can fly up in the sky in Korea. And with the advanced controlling technology, you'd see the types of advanced controlling or surveillance equipments, or FIMs. These are the core technologies of K drone system. And the Korean government is supporting R&D projects. It also encourages public to take part in the demonstration projects. And we are collecting information from those demonstration projects. And all the research results will be collected to this FIM system, which will be shared among all the operators or key stakeholders. So drone and UAM can only fly within BLOS, but within the BLOS. But over time, in a few years' time,
수 있고 다른 비행기가
we can expand it further.
그러면 이 드론이 5천만 원짜리 드론
Let's say there can be a tree in the way ahead of the drone.
이 사업 루트를 발굴했었을 때
So
우리가 직접
when we set the corridors for the operation of drone,
확보한 상태에서
we are not doing it out of scratch. We
확보한 상태에서
set those kind of potential corridors based on all the information collected from related organizations.
제시해 줄 수 있는 교통관리 기능이 있다라면 미래의 사업자들은
So that
될
is
것입니다.
that is why we need to build this kind of system that can collect all the related information to set the most feasible and potential route for the drones.
자기의 드론은 볼 수 있지만
The key is
다른 유인 항공기의 움직임은 볼 수 없다.
what's
새롭게 생긴 장애물은
what
볼 수 없다.
the greatest challenge is that
하나 있을 충돌이나 이런 거에서는
drone operators cannot see what are the routes for the other drones. That's the biggest challenge for the time being. So
기본적인 기능이
that will be
기능도 계속 개발.
how we can overcome and address that challenge will be one of our tasks.
또 하나는
To do that, the participation from the government organization is needed,
가능할 것이다.
and
교통법에
also the large private companies
될 때 필요할 PSU에 관한 사항이 들어가야 될 거라고.
can also take part.
그래서 그러면 기체와
So
어떤 구조와 이 시스템과
there,
이어주기 위해서는
in order to connect flight,
필요합니다. 그래서
the fuselage and users, we need a terminal. So this is a UTI which can do that.
다르고 그 다음에가 다르고
We are at the initial stage for this device.
가지고 있고요.
Over time,
어디에서든지 활용할
the device can get smaller
모바일 기반
and will be more easy to use.
비행 신청을 할 수 있고 가운데 보이시는 화면은
So in the middle is a UTM. It's the screen that can be used by drone operators. We can make this possible.
항공우주연구원에 있고요.
So our headquarters is located. This headquarters is located in Daejeon.
그래 보이지 않을 거 아닙니까? 그래서 실제 강원도 영월에서도 진행을
But we also hosted tests in Yeongwol, in Gangwon, as well as all the places across the country.
했는데요. 각 드론별로
So each drone had different missions when we did our demonstration.
해서 다 진행을 하고 있고요.
So this is how we utilize a UTM system. So we
마지막으로
will
본격적인 사업을 시켜드리면서
take this project to the next level around January next year. Well, let me share my childhood story. I had this little automobile toy.
실어보고
When I first had this toy, I played with it at home. But over time, I took it outside and played with my friends. So why I'm telling
사람이 타고 나르기
you this story
화물부터 나르고
is
승객을
it is the same with the UAM and drones. These are the new types of
어떤 항구의
new modes of transportation. And we are at the very early stage of the development, but over time it will be further developed and enhanced.
이 사람들
And
가 뭐가 있을까 해서 드론을 가지고
there's a
물건을 배달하는 걸 시작을 해봤습니다. 처음에는
and also there's a businessman who had tried this idea of using drone to deliver products to their users. At the initial stage,
비용도 쌀 뿐더러
the shipping cost was really expensive when not using drones but using conventional ships.
이제는
So
알리는
this businessman started to use this idea of using drone to deliver products that is relatively light, maybe the goods, little tiny goods or products.
해왔을 때 저희가
So we believe this can be a really great idea.
반응이 정말 폭발적이었습니다.
And we, on our part, supported companies with innovative ideas such as this to expand their businesses.
그래서 이렇게 쌓인 데이터들을 향후
And based on our data collected from all these demonstration projects or R&D projects, we'll be able to take our UIM project to the next level. So
어반 스카이입니다. 그래서
our initial slogan was "Open the urban sky," but these days we have new slogan "Into the urban sky." Thank you so much, Mr. Park, for your insightful presentation. On to the next speaker, I'd like to introduce a speaker from Professor James Wang from Nanyang Technical University. Mr. James? Professor James, are you there?
Hello? Can you hear me?
Yes, please go ahead.
Okay. All right. Thank you for inviting me to give the presentation. Today I'll talk about, sorry, very sorry. Today I'll take a look into what is the future of urban air mobility. So I'll focus specifically only on the man-carrying eVTOL aircraft. Okay. So my background is designing eVTOL aircraft and also been working on the AAM, UAM field for the last 10 years. Okay. So we all know that today there's a worldwide traffic problem in every city, major city in the world. And so my dream started 2010 was to design an eVTOL aircraft that can help solve the future of transportation. So this is the eVTOL aircraft I designed back in 2010. I call it the Project Zero. So the Project Zero, it was the world's first eVTOL aircraft. So I designed this in 2010. We successfully flown it in 2011, and then we reviewed it in 2013, the Paris Air Show. So since 2013, there are very few eVTOL companies in the world. As you can see, I'm plotting here on the horizontal axis the years, vertical axis the number of eVTOL company or OEM that are working on the eVTOL aircraft. So between 2010 to 2015, there are very few. However, if we look at today, 2022, there are over 400 startups and companies working in the eVTOL field. Majority of these startups, they're all in the preliminary design phase. Very few are in the certification stage, and none of them has received a type certificate from the FAA or EASA. Majority of these 400 startups, they will not make it because either lacking eVTOL aircraft design expertise or lacking funding. But even 10% of these 400 companies make it in the next 10 years, it will still be 40 companies making eVTOL in the next decade. This is my estimate of how much investment funding worldwide has been spent on eVTOL aircraft in the ecosystem. When I say ecosystem, including the eVTOL aircraft, also vertiports, infrastructure, and other facilities to help promote eVTOL. And the vertical axis, the US in terms of billions of dollars. Today, up to 2022, the world has invested about $3 billion already. By 2030, it will go to as much as $20 billion. This chart shows some of the venture capitalists, the VC, and corporate venture that have already invested in eVTOL. These dollars amount are fundings, they're not valuation. So on the left side, you see some of the famous startup company. For example, Joby, they currently have a funding of $1.8 billion US. The investor includes Toyota, Intel, JetBlue, and they went IPO on February 2021. The other company, including Lithium from Germany, currently they have $930 million. Archer from the US at $850 million. Beta Technology, $510 million. So the rest include Eve, Whisk, Vertical Aerospace, Volocopter, Ehan, SkyDrive, Overair. And if you notice, Overair is invested by the Korean Hanwha System. Currently, Hanwha has invested $25 million in Overair. So these are the top 12 eVTOL companies in the world. As you can see, there are many investors from different companies around the world. They including companies like Google, Amazon, Federal Express, Boeing, Porsche car maker, and the Mitsui Sumitomo Bank. So they come from all different industries. It is very interesting now. If we take a look at some of these top companies, there are many cross-industry collaboration. For example, Archer from the United States is collaborating with Fiat Chrysler, the car maker, and United Airlines. Boeing is working with Kitty Hawk and Porsche, car company from Germany. Airbus is working with Rolls-Royce, an Audi car company. Joby is working with Toyota and Uber and US Air Force Agility Prime. So I have provided these slides to our event organizer, so you will be able to see these slides later on and study them. Here is the predicted, the eVTOL market size for both people carrying and also cargo. This is done by Morgan Stanley in 2021. So as you can see, they've shown 3 different lines, the green line, the dark blue line, and the light blue line. These are the different forecasts for how big the ecosystem can be for the AAM. Let's take a look at the dark blue line, which represents the baseline case. In the baseline case, Morgan Stanley predicts by 2040, the market size will be $1 trillion. If we're more optimistic, the light blue line shows by 2040, it could be almost $5 trillion. If we're more conservative, then the green line shows at 2040, it still will be as large as $500 billion. So it's a very optimistic for the future urban air mobility market. That's why there's so many startups and companies all want to get into AAM. This is a prediction that shows in the future by 2035, where would be the usage of the urban air mobility. 25% will be in Europe and the rest of the world, 30% will be America, 45% will be in Asia Pacific. So Asia Pacific including Korea, Japan, China, Singapore, and all the Asian countries. So as you can see, Asia Pacific will be the largest user of urban air mobility. In this chart, let's present you the human carrying eVTOL adaptation curve. So back in 2010 and 2020, that was when eVTOL ideas was just started. And that was when I invented the Project Zero eVTOL. So it's a stealth and prototype. There are very few companies working on it. And from 2020 to 2025, this is what we call the proof of concept stage. And also, companies started engaging the regulatory. Regulatory means like FAA and EASA. Stage 3, 2025 to 2030. This is the stage where different countries and cities will start exploring urban air mobility. I believe 12 cities around the world will try UAM between 2025 and 2030. In stage 4, this is what we call initial commercial deployment. And I believe UAM will expand to more cities around the world. It could be as much as 100 cities around the world. And by stage 5, that is 2040 and beyond, this becomes the large-scale deployment of urban air mobility. This is where the prediction of the ecosystem will be $1.5 trillion or more. So let's take a look. So when we talk about 2025, initially this is what a vertiport could look like. It's a very small vertiport. You will have a holding pad for 2 or 3 eVTOL aircraft, and you have 1 takeoff pad. So it's a very small vertiport. But this is by 2025, it's very soon, almost 3 years from that. In Singapore, we'll be building one of these already. And then starting in 2023, 2024, we'll be providing sightseeing service using one of these eVTOL. Here's another example of a small vertiport for a single eVTOL aircraft, where the eVTOL would land on top of the roof, and on the bottom, you can see the charging station, you can also see the office, and this is where the passenger will check in. By 2028, we can probably start seeing some medium-sized rooftop vertiport building on top of buildings, hospital, and shopping mall. So this is what I call a medium size, because it can only hold a few eVTOL at a time. People will travel in the future from vertiport to vertiport. And initially, there'll be very few vertiports per city, maybe only 5 or 6 vertiports by 2025 to 2030. However, as we go to beyond the next decade, from 2030 to 2035 to 2040, we may see many more air taxi hubs per city. For example, this is a top view of Los Angeles City. Here we can see about 20 vertiports, all located at different locations in the city. And each vertiport or air taxi hub could be as far as 20 kilometers to 25 or 30 kilometers. And you can catch from one place to the other. And here's an example of what we call a mega vertiport. This could happen maybe by 2035 to 2040. This will allow simultaneously many eVTOL aircraft to come in for landing at different locations on the path, and could simultaneously allow eVTOL to simultaneously take off. With a design like this, it could possibly move thousands of passengers every hour. And this is what we call a mega vertiport. Now let me show an example. What could possibly be the cost of riding these eVTOL aircraft in the future? Here is a map of downtown Los Angeles. So let's say we want to travel from Los Angeles International Airport, LAX, all the way to downtown Los Angeles. So these are the highways and the road in Los Angeles. So if we take a taxi, we take the blue highway road, the blue line will show it takes 30 to 80 minutes, depending on traffic. The distance, 16.7 miles, will cost you $65 US. If we are able to fly on an eVTOL, we can fly directly from Los Angeles Airport to downtown Los Angeles. It'll be only 10 miles, take you 8 minutes, and cost you $60. It costs you $60 because initially, by 2028, we could assume company will be charging $6 per passenger per mile. Now, how can eVTOL help reduce the air mobility price? Let's take a look. On the chart here, I'm showing the cost of 3 different transportation systems: helicopter, urban air mobility, and taxi. Today, there are many cities around the world, like for example, Rio de Janeiro in Brazil and New York. They already use taxi already use helicopter for air taxi. And right now, currently, they're charging the helicopter price at $14 US per passenger per mile. Today, the taxi cost is about $2.50 per passenger per mile. So initially, we can expect the eVTOL aircraft will charge about $6 per passenger per mile. The goal is by 2032, we would like to see if we can reduce that to the same price as a taxi, $2.50. Okay. Why are we able to reduce the price of the eVTOL compared to flying helicopter? Because let's take a look. In 2027, we forecast a typical 5-passenger helicopter, like on the left, will cost US $3.5 million, while a small eVTOL aircraft, it could cost $2.5 million. And by 2032, the price of the eVTOL could drop down to $2 million. Why is there a price dropping? The reason is because helicopter has many parts. They're very expensive to buy, very expensive to operate and maintain. While electric vehicles have much fewer parts. Here's an example electric car. All you have is the motor control, and the battery. While most car with an engine needs about 30,000 parts, an electric vehicle typically only has about 11,000 parts. So we can expect the same level of reduction from 30,000 parts to 11,000 parts. That's a reduction of about 66% when we change from a helicopter to a electric eVTOL aircraft. However, eVTOL aircraft is not going to replace all helicopter. Let's take a look at helicopter versus eVTOL aircraft. On the pro side, the benefit of helicopter is they're proven, reliable, safe, they're certifiable for long endurance, long range, trustworthy, that large payload, as much as 50% of the maximum gross weight can be carrying payload. The negative side, the con side, mechanically complex, more parts, expensive to maintain. Now let's take a look at eVTOL aircraft. The pros are, it may be quieter, fewer parts, lower cost of ownership. They're very cool, they're very hip. It's a game-changing idea. On the con side, they're unproven, cannot auto-rotate if lost power, short endurance, and short range because of battery, and very low payload capability. Usually, it can only carry 15%, that's 15% of the whole aircraft weight as payload. This is my predicted range versus year for eVTOL aircraft. On the vertical axis is the range in kilometer, horizontal axis is the year. Here I have shown the blue line that today, 2020, our technology now already allow us to fly eVTOL for 100 kilometers. And by 2030, we could able to do 200 kilometers or more. And by 2040, we should be able to do at least 500 kilometers or more. Most of the benefit of the improved range comes from the improvement in the battery. Here on the horizontal, I have shown what is the battery's specific energy level. Today, we can reach 180 watt-hour per kilogram. By 2030, we should be able to reach 350 watt-hour per kilogram. By 2040, I predict at least 750 watt-hour per kilogram. And for intra-city, which means traveling within the city, like inside Seoul, or inside Tokyo, or inside Beijing, typically you're under 60 kilometer range. And for intercity, means travel between city and city. As you can see, today, eVTOL are already good enough to allow intercity travel. If you're a little more optimistic, we can expect even higher range due to better eVTOL aircraft design and even better battery. Now, let's take a look. This is a German company, Liliums. Their goal is to fly at 300 kilometers an hour speed with 300 kilometer range. That means they can fly from London across the English Channel to France. It may not be quite able to reach Paris, but at least it can cross the English Channel. Here, the same Lilium aircraft, the eVTOL, is designed to also fly you between many different cities in Northern California. For example, from San Francisco to Lake Tahoe for skiing. And in Europe, the same 300 kilometer range allows you to travel between 5 different countries, from Germany, France, Switzerland, Austria, and Italy. You can easily fly from Zurich all the way to Geneva, or from Geneva to Milan. Now let me talk about who will be the key players in urban air mobility ecosystem. I believe there are basically 5 key players. These are the 5. First one, the eVTOL OEM supplier. OEM stands for Original Equipment Manufacturer. They are the company that will design and manufacture eVTOL aircraft. The supplier could be Tier 1 or Tier 2 supplier. The second group is what I call the lessor, or owners of the eVTOL. Lessor are usually banks or companies that will lease the aircraft. They'll buy the aircraft and lease it out to operator. And the third group is called the operator. Operator are the group that operates and maintains the eVTOL aircraft for revenue. The fourth group are the infrastructure group. Infrastructure group are the one that operate vertiport, operate a charging facility. They also provide traffic management for eVTOL aircraft. Number 5, the fifth group is what I call the rideshare apps. They are the one that the passenger can go to their smartphone and then reserve this eVTOL aircraft. So initially, these 5 groups, let's see how much money they'll be investing in terms of percentage. Initially, this represents between 2025 and 2030. Initially, most of the investment will be invested, as is shown by the red color, by the eVTOL hardware manufacturer and supplier, because they have to invest a lot of money to design and build these aircraft. Initially, the lessor and owner, the green one, they will also invest money to buy the eVTOL aircraft from the manufacturer, and then they'll be leasing to the operator. The operator will be spending the least amount of money because they do not own the money. They will lease from the lessor. And the other 2 groups are the infrastructure. Infrastructure groups have to spend a lot of money to build the vertiport, to build the heliport, to allow these eVTOL to take off and land. So they have to spend the money to build the structures. The rideshare apps, they're the one like the Uber, and they provide the software to allow customers to order taxi and also to order this eVTOL aircraft. So their investment is on developing this app, the software. Now let's see about the revenue side now. The revenue side is the income. The initial revenue from 2025 to 2035. So these are the first 10 years after urban air mobility start. Half of the revenue of the ecosystem will go to the eVTOL manufacturer because they will be the ones selling many of these eVTOL aircraft. The lessor or the bank, they will have very little income because their incomes, they'll be spending a lot of money buying eVTOL aircraft, but their income coming from the operator paying them back. The operator will have a significant amount of income because every time the passenger fly, they pay the operator. Infrastructure will also have a steady income because they will be charging for takeoff fee, landing fee, battery charging, using their vertiport. That's how they recuperate their investment. And the rideshare app people will also have a very steady income because every time a passenger uses the smartphone, the app to reserve, the app service will also charge a fee. Now let's take a look. What is the steady state revenue beyond 2035 and in the future? Once we reach the future, the number of aircraft becomes steady, and the revenue of the eVTOL aircraft manufacturer, they will still get huge income. However, but the majority of income will go to the operator because by 2035 and beyond, there will be many eVTOL aircraft flying around the world. So the operator will make very good revenue. Same as the infrastructure, they'll continue to make revenue. The rideshare will also continue to make revenue. The income for the lessor is very steady because the operator only pays the lessor at a steady monthly leasing fee. Some eVTOL OEMs, for example, like Volocopter and Joby and Lilium, and they're very ambitious. They want full vertical integration. What does that mean? For example, rather than having the 5 different parties, even though Volocopter is the OEM manufacturing eVTOL aircraft, but they want to get into the right app business. They also want to get into the operation of their own aircraft. They also want to do the management of traffic, and they want to run the flight hub to operate, and they also want to provide drones and the fleet development of new eVTOL. So that's what I call it vertical integration. Another company, OEM, like Bell Helicopter from the US, Bell is now also focusing on developing both manned eVTOL, cargo drone, and operation app. This is my conservative forecast for manned eVTOL demand worldwide for urban air mobility and usage. Today, there's 0 eVTOL flying, doing 0 trips per year. Between 2025 to 2030, there could be as much as 1,000 eVTOL aircraft flying around the world, doing 4 million trips per year. Between 2030 to 2040, there could be 20,000 eVTOL doing 100 million trips per year. Beyond 2040, we can expect over 2 million eVTOLs around the world, doing 10 billion trips per year. Now let's estimate how many eVTOL aircraft will be produced in 2030. So what I'm showing here on the horizontal axis, the number of aircraft produced, vertical axis, the number of OEM company. So let's assume there are 8 OEM company that has received type certificate by 2030. So 2 OEMs will produce 100 eVTOLs aircraft per year. So here are the 2 OEM. There's 2 OEM, each produce 100. And let's say there are 4 OEM aircraft companies. Each one of these 4 companies will produce 200 eVTOL aircraft per year. Let's say there are 2 OEM companies, each will produce 300 aircraft per year. So in total, we will have 2 times 100, 4 times 200, and 2 times 300, total 1,600 eVTOL aircraft produced per year by 2030. So that's my forecast. And let's take a look, how much is that dollar-wise? Assume there are 1,600 eVTOL aircraft produced per year. Let's assume there's about 2.2 million US dollar per aircraft at today's dollar. That means the annual aircraft sales will be 1,600 times 2.2 million equals $3.52 billion by 2030. Let's compare this to the forecast, the global new civil helicopter sale for 2030, which could be around US $6 to $8 billion annually, not including spares, supports, and training. So this is pretty good. For new industry, we can provide 3.52 billion per year. Now let's estimate how much eVTOL aircraft could be produced by 2040. So here is my guess. Assume there will be 40 OEM company has received type certificate by 2040. Let's say there are 10 OEM company producing 1,000 eVTOL aircraft per year. So it's 1,000 aircraft, 10 of them. Let's go to 2,000. Let's say there are 20 OEMs producing 2,000 aircraft per year. And there are 3,000, sorry, and there are another 10 OEM produce 3,000 aircraft. So in total, there'll be 80,000 eVTOL aircraft produced per year by 1940. So assume that there are 80,000 eVTOL aircraft produced by year, even though the price of eVTOL has gone down now to $1.6 million because of increased volume. This will still give you an annual aircraft sale of 80,000 eVTOL aircraft times 1.6 million equals $128 billion revenue. If we add the spares and support, this could easily equal to $200 billion. Now, if an eVTOL aircraft hardware, the company is equal to 15% of the total manned air mobility ecosystem. What do I mean by 15%? Let's take a look at the pie chart I have provided before, right? This is a steady state 2035 revenue. The eVTOL hardware represents about 15% of the entire ecosystem. So let's calculate $200 billion divided by 0.15. That means the entire pie would equal to US $1.3 trillion, which is the entire pie. This is very similar to what I've shown before earlier, that by 2040, we could expect $1 trillion for the market. The aircraft price in general, they will keep on reducing as the year goes on because more units will be produced. Here, let me show you. On the blue line, it shows that between 2025 to 2040, we expect the number of eVTOL aircraft produced to continuously increase. At the same time, assuming at 2025, the average eVTOL price will be around 2.7 million US dollar, and it could go somewhere between 2 million to 3.5 million at this range. Let's assume the average 2.7 million. As the volume increases, the price of eVTOL aircraft will continue to drop, which is very beneficial to stimulate the urban air mobility market. One of the biggest contributors is the battery price. The battery price will help reduce the eVTOL cost. Here, I'm showing the horizontally is the year. Vertically axis, the dark blue color represent the cost of the cell. The vertical, the blue bar represent the battery, the finished pack. Let's take a look back in 2010. The battery pack price is about $650 per kilowatt hour. Today, that price has dropped down to 120 US dollar per kilowatt hour for the battery pack. This is currently the price that are paid by car company like Audi, Tesla, BMW, Toyota. In the future, we can continue to expect the price to come down. However, aviation battery could easily cost 2 to 3 times more than what we've seen here for the electric car. The reason is because aviation requires stringent safety and more battery management system check. This is the technology chart. So today, what is the batteries, the lithium battery specific energy, the vertical axis, plotted watts hour per kilogram versus the specific power it can come out. And we have different type of battery compared. Lead acid, nickel metal hydride, lithium ion. Today, the red line represents today's technology, which basically we can have 250 watt hour per kilogram as the specific energy. In the future, by 2030, I predict we will be able to achieve 500 watt hour per kilogram. We'll be able to achieve at least 1,500 or more watt per kilogram specific power. By 2040, the target is we would like to achieve 1,000 watt hour per kilogram and 2,500 watt per kilogram. So if you're going to design an eVTOL aircraft, these are targets. Hopefully, we can achieve the battery for you to use. We may start to see also hydrogen fuel cell aircraft in use by 2030. I don't believe we'll have eVTOL hydrogen aircraft before 2030 because the technology is not mature yet. So for hydrogen to work, they could use the sun or the solar panel or the wind turbine to basically do electrolysis to break down water into hydrogen. And the hydrogen can be used with fuel cell to power electric airplane. There are many companies that already work in hydrogen powered fuel cell airplane, but it's not been certified yet. I think there's still a few more years to go. Finally, what are the key challenges to eVTOL and urban air mobility? We still need to fine-tune the technologies, create appropriate infrastructure. That means vertiport, regulation, how are we going to control the flying of so many eVTOL aircraft? We need collaboration and partnership between the design, the government, the academic, and supply chain. We need to regulate entire new industry. We need to overcome the public psychological barrier. What does that mean? People may be afraid to get on these small 5-passenger eVTOL aircraft. That is a psychological barrier. Finally, we need to have public acceptance and affordability. Public acceptance is that noise and also visual pollution. Because do we want to see an aircraft fly above our house, above our building all the time? That is what I call visual pollution. Affordability. Can the price be come down cheap enough to compete with car? Then everyone, and not just the rich people, can fly on these eVTOL aircraft. This is my motto. I always say, if it can be dreamed, it can be built. And I believe air mobility is coming. Since I designed the first Project Zero in 2010, I believe that one day we will have urban air mobility. I think the years are coming. By 2025, we should see some company start operating some city with urban air mobility. Thank you very much. If you have more questions or you'd like to contact me for any discussion, you can reach me at my email address shown here. Thank you, everyone.
네, 제임스 황 교수님 발표 감사합니다.
Thank you, Professor Huang. Thank you so much for your insightful presentation. Please give him a big hand. So in Singapore, we believe that UAM, the Singapore government is making a lot of efforts in expediting UAM operation. So, as Professor Wang has said, the UAM business and industry is highly developed. So thank you so much, Professor, for your insightful presentation. Due to the COVID situation, we are not able to invite our overseas experts here with us in Korea, but in few years' time, we expect to see them here, probably next year. So we will go into the Q&A session for the first section under the title National Effort and Strategy for Introduction of Commercial AAM Service. So I think I'd like to first invite Director Na Jin-hang from MOLIT to the stage, and we will also move to the center stage. Thank you.
네, 온라인으로 참여하시는 분들께서는요.
For those of you who are joining us online, you can leave your comments in the leave your questions in the comments. So UAM, AAM, all of you here are very familiar to these terms, and I learned these terms through this occasion, but many others might find this quite new. Maybe it would be easier for them to understand if these terms were said like as in unmanned the air mobility. So this UAM, this term was first introduced in 2019. We've been thinking a lot about how to introduce this concept more easily to the public, and I think we have made it into a brand with the term UAM. But the scope of this term is expanding, and maybe we need to think about how to help our people understand the term better. I'm wondering whether you watched the movie Exit. There are drones in the movie following others in the scene. So I didn't really watch the movie when it was first released, but I realized that without UAM, we couldn't really make this kind of movie either. So maybe you can ask the questions we have. So I collected some questions from the comment section of the online platforms. So now we're expecting the rise of UAM as a new service. Maybe it's time to develop regulations and systems. Unlike the conventional transport system, we need to consider the characteristics of UAM, and we'd like to think about how we need to proceed in the future in Korea. We have many experts who already explained the concept of UAM, and this is a lot in common with the traditional air transport, but it's really hard to direct the development of the industry. We have to build an overall ecosystem, and we're now preparing a special bill to help and support the industry. We also need to consider the acceptability of the public as well. This is not something we have to actively walk the words. We have to conduct demonstrations. I think the Korea challenge, the grand challenge, will allow us to verify or validate our idea. For example, this vehicle can fly up to like 300 or 600 meters above the ground. So we need to verify the safety through these kinds of demonstration projects. I think you gave us a great answer, but maybe I'd like to ask you one more question. As you mentioned, KUAM roadmap, KUAM CONOPS, and there are other terms, and all these combined are driving the UAM services here in Korea. To validate the safety should be tested across the society. So what is now being planned for this? I think this is all connected. KUAM Grand Challenge will provide an opportunity to prove and demonstrate the idea. I think we all need to see with our eyes to make sure it really works. I think we started about like 2 years ago, from like 2019. So we've been preparing and conducting demonstration projects. Also, we all had another successful case last year, and we're also preparing for more this year. If we go through these steps, and I think as Dr. James Hwang mentioned earlier, the psychological barrier will be lowered and eliminated to actually ultimately activate UAM industry.
And next, I'd like to ask questions to Mr. James Hwang from Singapore. Professor Hwang, can you hear us?
네, 저는 질문을 한글로 하고, 네.
I will ask your question in English, and you will hear English interpretation. So, Mr. Hwang, you have more than 3 years experience in the aerospace field. What are the key differences between traditional aerospace and the UAM you have experienced so far? And can you tell us what you think are the most important factors for a successful implementation of UAM services?
I would say there are many similarities and many differences between traditional aerospace and also UAM or eVTOL aircraft. Because the similarity are, yes, they both need to require to meet a very stringent safety standard, just like we impose on any of the Airbus and Boeing aircraft flying. We cannot have any crashes or accidents. However, all the participants, the people that are starting the eVTOL, the company, majority of them, they are not from aerospace company. Out of 400 startup companies, they have no aerospace industry experience at all. They've never designed any aircraft before. Most of these founders, the CEO, they are entrepreneurs. They come from Silicon Valley, investors or entrepreneurs, and they do not know anything about the aviation. However, but they believe a dream. So they're dreamers. They're people that want to build a future. So what they need to learn is learn and work with the aviation industry to learn how to safely design them, how to make them certifiable, and how to do the testing. Give you one good example is, it takes about 7 to 10 years to design any aircraft. It takes 10 years to design the Boeing Dreamliner, right? But however, all these new startups, they believe they can design and certify an all-new eVTOL aircraft in just 4 years or 5 years, which is not very realistic at all. So I would recommend the people who want to start building eVTOL, they should really hire people who have really worked in the aviation industry and work with them together, then combine with smart people from other fields. For example, people from the electronic industry, software industry, autonomous industry. Together, then they can really make a revolutionary and fantastic eVTOL aircraft.
네, 교수님 답변.
Thank you, Professor, so much for your insightful comments. I'd like to ask Professor Hwang another question. So UAM is built to overcome the traffic in urban cities, and we also need to think about the environmental factors. So considering the unique situation environment of Singapore, what do you think are the challenges to overcome for reliable UAM services in Singapore?
Okay, so there are a few key parameters. Number one is noise. Fortunately, companies like Joby, Archer, Beta, they have already demonstrated this electric VTOL aircraft. They're about 15 dBs quieter than helicopter. So that's one good thing. The second thing is I mentioned earlier is the psychological barrier. Will people get onto an eVTOL aircraft, right? Especially, where are we going to find thousands of pilots to fly this eVTOL aircraft, right? It's not like finding a taxi driver to drive the Grab. So we need to train pilots. We need thousands of them in order to make UAM work. Even though most of the eVTOL aircraft today, they're all designed to be autonomous capable, means flying by itself, go from point A to B. But will you be brave enough to get onto an eVTOL aircraft when you see there's no pilot and you just get on and fly it? So that's a psychological barrier, right? And also in the beginning, the next 10, 15 years, I believe we will only have urban air mobility to going from point to point. It's like a bus system or subway system in the sky. We will not likely to see eVTOL aircraft that will allow you to fly, say, come to your home, pick you up, or you own one, you can fly to work, you fly to shopping mall and come back, because that will pose a very big air traffic control problem. So there's still many things we need to learn in the next 10 to 15 years. But I do believe there's enough momentum and there's so much money invested into this eVTOL UAM ecosystem. So I believe this is actually a very good time for all the young engineers to get into aerospace. One more thing I'd like to mention is that this is a good time to start an eVTOL company. You need about $1 billion to go from beginning, 7 years later, produce a certified aircraft. That actually is not a lot of money, $1 billion. Why? Because 10 years ago, when Elon Musk started the Tesla company, he only put in less than $1 billion to start an electric car company. Today, if you want to start an electric car company, you have to put in about $20 to $50 billion US to start a car company. Same thing. Today, you only need $1 billion to start an eVTOL company. If we wait till 2030, if you want to start an eVTOL company, by 2030, you probably need to put in at least $5 to $10 billion. So if you want to start eVTOL, today is the right time to do it.
네, 교수님 말씀 감사합니다.
네, 사실 더 많은
Thank you so much, Professor Wang. Due to the interest of time, we will have to wrap up the Q&A session for the first section. Thank you so much, Director Na Jin-ang from MOLIT of Korea and Professor Wang from Singapore. Thank you so much.
자, 이제 두 번째 세션 이어가겠는데요.
Okay, let's proceed to session 2. And our Dr. Yoon Bum-soo will walk us through today afternoon's presentation and discussion panel. Well, let me give a brief introduction of this afternoon session. We are going to mostly talk about the national R&D and demonstration projects. So we're going to start with the domestic UAM airport demonstration program, and it will be followed by the domestic UAM development and related research trends, and also the overseas demonstration projects and progress. So let me introduce you the first presenter for the second session. We will going to have Kwon Tae-hwa from the KIAST, and he will going to make a presentation on the Korea's UAM airport demonstration program. Please give him a big round of applause.
저는 영어로 발표하겠습니다.
Good morning, everyone. I will give you a presentation in Korean.
I am an aircraft conceptual design engineer by training. Now, I am doing a research on UAS and UAM certification at AAM Technical Center of KIAST. Today, I'd like to talk about UAM demonstration project that I have been involved in since the beginning of last year. Also, I will speak about what we are going to do this year in the later part of my presentation. This talk is nothing about technology or engineering, but will cover a bit of regulatory framework, so please relax and enjoy. I will begin my talk with the project timeline, then we will speak about our efforts we have made to carry out the demonstration project. Then I will show you something about regulatory difference and the requirements we have experienced in the process of getting flight permission. Also, I will comment on the UTM system that we have tested. Also, I will finish my presentation with some of the key lessons learned together with a future plan. Let's have a look at the short video clip first. 비디오 좀 틀어주겠습니까? Could you please play the video now? I think Mr. Park from MOLIT has already showed a very nicely edited video of the whole story in the morning session, so this might look a bit boring. But I think this flight was the one performed at the public park near the Incheon airport. And now this radar screen shows a flight path of the aircraft. This really short flight has covered some 3 kilometers distance at a speed of maximum 25 knots and has reached some 50 meters height. Okay. Now I will briefly introduce the timeline for the flight demonstration project. This project was initiated in early January last year, led by the MOLIT, in order to promote the introduction of the UAM service and to improve social acceptability. In February, request for information was sent out to some 20 domestic and overseas eVTOL companies in order to secure the UAM aircraft that is needed for the program. Only a few companies showed a positive response, and an NDA was signed with a German eVTOL manufacturer for further communication in March. Next month, 2 different flight scenarios was proposed by the major airport corporations. Also, German eVTOL startup for air vehicle and the agency for the management of the event were finalized through the technical committees. Then we had a very busy summer last year as we signed an MOU for comprehensive cooperation between KIAST and the eVTOL company. Also, we had a site survey to fix the CONOPS, and KIAST visited Germany to double-check the readiness of the aircraft before applying for permission in Korea. After a long period of preparation, the formal application was lodged with the regional aviation office in Seoul, and all the permission issues were cleared. This was the single most difficult part during the whole process of the project. This next slide shows the effort we have made since the beginning of the project early last year. I have to say that it was a real challenge to arrange a flight with a piloted eVTOL aircraft. Many eVTOL companies are claiming that the development are progressing on schedule toward commercialization. However, most were reluctant to join the program with the excuse of focusing on certification. My personal understanding is that flight-ready air vehicles are not readily available yet. Only one German company showed their strong interest with their test aircraft, so we began to communicate in a deeper level, and they finally joined the project. During this long process, we exchanged well over 500 emails, mainly with the overseas eVTOL companies. This is not the end of our efforts. We had to have more than 100 online and offline meetings. The time difference between Korea and the European country means that we had to join the meeting anytime, day and night if necessary. In addition, in order to respond to the inquiries from the authorities in relation to the permission, as well as to prepare meeting minutes and the official documents, numerous technical data provided by the eVTOL company had to be thoroughly reviewed. Moreover, despite the difficult COVID situation, we decided to visit the eVTOL company in Germany in order to avoid any uncertainties in relation to the aircraft and flight permission. This visit was quite successful because we could have witnessed the actual flight on their test site, which showed satisfactory performance in terms of distance and duration required for the demonstration. As all of you may be well aware, there are many uncertainties in relation to the eVTOL aircraft, which is a vital element of the UAM service. We have no regulatory framework for eVTOL or something similar to this type of aircraft. Of course, there exist pathways that you can apply for a type certificate of a new type of aircraft, and this certainly includes eVTOL aircraft. However, not all authorities are ready to accept such new aircraft for certification, to be honest. I cannot explain every single details about the certification process under the Korean Aviation Safety Act. Instead, in short, if you have an aircraft that is registered in Korea, you can apply for airworthiness certificate, including special airworthiness certificate. As you can see from the photo in the middle, Ihang has got an HL number on its body, which means this aircraft is registered in Korea. Therefore, this one is eligible for an airworthiness certificate. Volocopter on the right hand, however, is registered in Germany. The registration number DMEVC is definitely from the German authorities. This means that this aircraft is not subject to airworthiness certification in Korea. As per the ICAO rule, only the state of registry may only issue a certificate of airworthiness for registered aircraft. Now, I would like to get into a bit more details about what sort of permissions we needed to carry out the flight demonstration last year at 2 airports. First, as already commented, domestic use of foreign registered aircraft was the definitely one we had to sort out. This permission is normally issued based on a certificate of airworthiness of an aircraft. However, in the case of Volocopter, this was not available, as Volocopter 2X is classified as an ultralight under the German regulation. So we instead tried to prove its airworthiness via alternative evidence provided by the manufacturer. Sorry to say, but I cannot say more about this due to the confidential information involved. Other than the permission for the aircraft itself, permission for operation below minimum flight altitude was needed to fly below the minimum flight altitude prescribed in the Aviation Safety Act. Also, in the case of the Incheon demonstration, which was performed in the public park near the airport, permission for takeoff and landing other than takeoff and landing site was needed. Then, in order to provide a means to communicate between the aircraft and the ground control under the airport environment, we also needed a radio license for the VHF equipment. Also, the frequency had to be allocated to avoid any conflict with other airliners operating within the same ATC area. Finally, NOTAM has been issued to prohibit the access of other aircraft to the airspace where the demonstration took place. Another important item that had to be considered here was that the Incheon Airport is one of the busiest airports in the world, so we had to try to minimize the duration of the NOTAM. Well, this demonstration included not only simple flight, but also verification of UTM technology to confirm that the UAM aircraft can safely fly within controlled airspace. Toward this end, we tested the system's ability to display both manned aircraft and drones in one radar system using the air traffic monitoring system called ARTS, which means Automated Radar Terminal System, developed in-house by a telecommunication company. A green marker on the screen shows the path of the drone, which we assumed here was delivering a passport to the UAM passenger. A small transponder has been developed and attached to the delivery drone so that we can confirm the ability of the system. This can do the similar role to the ADS-B, which is currently widely used on manned aircraft, providing flight information to the other aircraft. In addition to this, the function of the swim system has also been tested during the short flight over the controlled airspace on the airport environment. SWIM means here system-wide information management. This SIM system can display aircraft and flight information, including identification, speed, altitude, so that the control tower can maintain its authority to cope with any emergency situation. There is no doubt that such UTM technologies as SWIM and ARTS are essential for the safe operation of UAM service. Therefore, I am confident to say that the successful validation of UTM system through the airport demonstration program means that we are now ready to introduce the UAM service from the operational perspectives, at least. Okay, finally, I'd like to share some of the key lessons we have learned from the flight demonstration project. First, Participating stakeholders may have different areas of interest they wish to get from the demonstration, and this sometimes may lead to conflict of opinions. But we were able to resolve the difference of interest through consensus building that the safe flight is the top priority. The second is the importance of the contingency plan. Given the nature of UAM flight, which has not yet been technically matured and which has no regulatory framework, there exist many uncertainties. With this in mind, from the early stage of the project, we always asked ourselves what-if situations and prepared for contingency plans. Next, we came to understand once again that it is necessary to coordinate well in advance with not only the eVTOL manufacturer but also authorities regarding permissions. Lastly, and most importantly, without strong commitment from all the stakeholders, including government agencies, eVTOL manufacturer, and the general public, toward the introduction of UAM service in Korea, this project could not have been successful, I can say. This final slide shows a short story of the flight demonstration we have done so far. In 2020, the first eVTOL aircraft from Chinese manufacturer flew in Korean airspace over the Han River with no pilot on board. This marked the first eVTOL flight of its kind in Korea and attracted many spectators. I would say that this event was very successful in that general public could have an opportunity to witness the actual flight of an eVTOL aircraft. Last year, in 2021, we aimed to fly an eVTOL in a piloted mode within airport environment, which was more successful than expected. Now, in 2022, we just began to talk about demonstration project this year. Many are still claiming that they are targeting commercial service in 2024 or 2025 or so. On the other hand, many are forecasting that some or long delays are inevitable. No one knows the definite answer. Nevertheless, we are here today because all of us are looking forward to UAM service for good reasons. One of them, I can tell you, is that this is essential from the public interest point of view. So I'm confident that flight demonstration project we have done and we are going to do will play a key role by promoting social acceptance as well as by validating technological advancement. Also, such program will be an opportunity to prove government's long-term plan is advancing under control. This time, we may well try autonomous flight or try to carry passengers flying over populated area with hopefully domestic eVTOL aircraft. It is too early to say something more than this. However, please expect something different from the previous one. We will make progress. Before closing my speech today, I'd like to say that my special thanks goes to those who have been and are involved in the demonstration project. Thank you.
네, 권태하 연구원님 발표 감사합니다. 제가 발표 하면서 좀 궁금한 게 생기는데 윤희정 아나운서님께서는 저희 이 권태현 연구원께서 발표해 주신 실증 행사 혹시 어떻게 보셨을까요?
저는 이제 재작년부터 그 실증과 관련된 프로그램에 좀 참여도 했었고 아나운서지만 또 실증 시연 행사를 한번 직접 보기도 했습니다.
I also participated in the program. I was wondering whether this is feasible, but I also have a high expectation that what we'll be able to see this year. So I think the arrival of the UAM service is very near, and I think it will arrive very soon, and it will be more exciting than our expectation.
다음 진행해 주시죠.
네.
Let's move on.
한번 모시겠습니다.
Okay, let me introduce the next speaker.
이라는 주제로 한국 항공
So our next speaker is Mr. Hwang Jang-chun of the Korea Aerospace Research Institute, or KARI. He'll make a presentation on OPAP Technology Demonstrator Program. Please welcome him with a big hand. Nice to meet you all.
아나운서님께서 발음을 잘해주셨는데요.
So
오에 대해서
our announcer has really knows the lingo. It is pronounced as OPAB. And for the next 20 minutes or so, I'd like to focus on OPAB, Technology Demonstrator Program. So this is what I'm going to cover during my presentation. So starting from the program summary, organization chart, development schedule, and the development status, and some results. So this is called the OPAB Technology Demonstrator Program. This is the official English name for the program. This is the Technology Demonstration Program. This is a demo. Please take a note that this is a demonstrator program. So the OPAB refers to optionally piloted personal air vehicle. So it means that the OPAB can go either way. It can have pilot on board, or it can also remotely piloted like UAV. That is why we are calling this demonstrator as OPAB.
카리에서 주관해서 개발하는 EV토를 명명하는
So
약간 고유명사화돼서
this
사용되기도 합니다.
OPAB, actually it was originally a generic term, but these days it is it is considered as the same as the eVTOL demonstrator that is being developed by KARI. So it concerns the two key technologies is the distributed propulsion system and the autonomous operation. So we need to have these two advanced technologies, and we need to take those two key technologies viable for this demonstrator to make this program successful. And we also consider the certification process and related methods, and also operation. The goals of the MOLIT covers the certification basis and preparing the draft for that, and compliance check and verification. So to tell you more details, so first let us look at the system specification and primary item development specification, or SS or PIDS. These are some of the things that are carried out by MOTI, or the Ministry of Trade, Industry and Energy. And as I've said, OPAB can be remotely piloted. So that is why we are also focused on those things. And also, in relation to that, there's a research program by MOLIT about certification, and there's also compliance check and verification. So when we are developing prototype, we carry out compliance checks and verification. And also, our ultimate goal is for the MOLIT is to develop draft for airworthiness standards. So we need to have this airworthiness standard at the same level as for the previous aerial vehicles.
우리 운항 기술 기준.
And also,
그다음에 이제
we
우리가
have
트랜스포테이션
flight
서비스 모델 해서 우리
transportation
코티에서
service model that is taken care of by COTI. These are some of the tests that are conducted by MOLIT. And this is the overall organization chart of the program. So there's KARI, which is Korea Aerospace Research Institute, that is a leading organization under MOLIT. And KARI is collaborating with industry leaders such as Hanwha. And also in the on your right, there's also KARI, which is a leading organization under MOTI. It is working with KAI, or the Korea Aerospace Industry, and also it is also in developing hardware and software. It is working with Hanwha System, Qtensec, and Real-Time Wave. And also the second project is conducted by KIAST, which is us. We are working with Konkuk University, and this project is about safety verification and safe operation. And fourth project is KOTI, or the Korea Transportation Institute. Their project is focused on transportation service model. So as you can see, there are four different projects on the MOLIT. As you can see at the bottom of this slide, all related stakeholders are closely cooperating with each other to carry out their tasks. So let's look at the development schedule. So UAM is a new type of aerial vehicle. So compared to UAV, OPAV can be developed a little faster. So we have started this OPAV program back in 2019, and we have carried out SRR, which is a system requirement review, and SER, which is a system design review, in the same year, which was 2019. And in 2020, we have completed our PDR, the preliminary design review. And in March last year, we have completed the critical design review. And this year, we are in the process of developing the prototype. And around June this year, we will do the TRR, which is a test readiness review. And around September, we will conduct FFRR. And if earlier, around October this year, we will be able to have our first flight. So by 2023, we will conduct a sufficient amount of tests for OPAV demonstrations. So that's our goal. At the bottom of the slide, you will see some letters in yellow. So starting early 2020, in order to improve software system, we have integrated our subscale prototype, and we were able to successfully conduct subscale first flight for the subscale model in November 2020. And in the first, we plan to have our full-scale test demonstrator first flight starting from the first quarter of 2022, and our goal is to complete everything by December 2023. So these are some of the documents that we have prepared for our PDR. So
글씨가 작아갖고 이제 상세한 건 안 보이시겠지만 각 항목별로 이제
the letters are a little hard to read, but
각각의 MOC를 어떻게 하고 그 MOC
so it shows
검증을
each different item
부분들에 다
and how the MOC and how we can carry out MOCs.
대략 한 150페이지 이상의
And
저희가 그런
this
걸
PDR
그래서,
is about
적용해서
150
하고
pages
있고요.
long.
중간 컬럼을 보시면
And in the middle, you will see that the loading condition and its analysis. And at the center, you can see the avionics architecture. And this is a fly-by-wire system. So it shows the architecture is really important and redundancy is important. Architecture is important because it needs to take care of both high voltage and low voltage. And since this is a PDR document, we need to include CFT analysis for hover download. And we have verified the load and weight. And we also carry out the wind tunnel test for aerodynamics. And also, and I'm going to talk about type certification in the later slides. Here, we have carried out all the calculations using the coefficient for our wind tunnel test. And these coefficients will play an important role for the smooth transition flight. So this is some of the results of the OPAP technology demonstrator prototype. So as you can see, these are how it looks. So you can see the front four propellers, tilt prop, and the back propeller, lift prop. And in cruise mode, it will stop. If you can see the wings, it is high wing. It is attached on top. So,
윙스팬이 한 7m 정도 되고요.
The full scale, if we can make this full scale, the wingspan will be 7. And the maximum speed will be 240 kilometers per hour, and the range will be 60 kilometers. And the benefit for this OPAP test demonstrator, it will be very easy to make it into a full-scale model. So in the future, we can have 5 seats. OPAP in the future. So at the moment, we are using the lithium-ion battery that is used for eVolt. We will be able to fly from Seoul to Daejeon much faster than the rapid railway. So some of the attributes of the OPAP TD is that we are using the tilt prop and thrust. We will be able to maximize thrust efficiency. And regarding actuator and electric systems, we are using OEI condition, which is one engineer system, and to ensure the safe flight. And rather compared to unwinged type, winged type can be much safer, and it can also do the gliding. And as for the lift prop, one of the biggest benefits is that drag minimum propulsion. The lift for lift farm is stopping cruise at drag minimum propulsion.
K800급의 국산 복합 재료를 쓰고 배터리 경우도
As for, we're using the Korean battery as well.
뭐 무엇보다도 우리가 플라이 컨트롤
And also, as for the flight control
아주 국내 개발
and
소프트웨어이기 때문에
the software, it is also locally developed.
엄청 이제 있는 부분.
We see there's
인증을 위해서
much room for growth
퀄리피케이션
and expansion in the future.
룰로 개발을 하고 있다는 거.
So we are in the process of developing this triple redundancy FC hardware and Korean controller equivalent to DO 178C qualification class.
시 정도를 보여드리고요.
And these are the title pages for our system specification or the PIDS. So for the OPAV. So as I've said, there are new technologies being adopted to OPAV vehicles and based on a vast amount of research and study.
강조해서 설명을 드립니다.
And we are quickly adopting and introducing new technologies to our model.
뭐 일부를 보여드리는데요.
And I'd like to also share some of our compliance check process.
물성치
For example, we are carrying out the test to test the material, physical, the characteristics of the materials
설계에 반영하고 있고요.
for the
중간 두 번째 컬럼
composite materials.
정적 구조 시험을 하기 위한
And also, we also conduct tests for the static structure.
계획이고요.
And these are our plans for our compliance check. And at the bottom,
부분에 대해서도 해석적으로 디자인
we plan to
3배 이상 되는 데까지 해석적으로 했을 때 플러터에 문제가 없다.
we see that there is no problem for our structure, even if we bring it to the 3 times of the design system for plotter.
전용 수직 이착력장 한 개
And we are also taking into consideration the dedicated pad, dedicated vertiport and charging station, and we have completed such vertiport at the end of the last year, and we did the test demonstration at night.
이거의 사이즈는 전체
And
세이프에리어가 33m by 33m.
As for the size, the safe area is 33 meter by 33 meters, so it is sufficient for a aerial vehicle with 5 seats. So if there are any companies in Korea that is interested in using this vertiport, you're welcome to do so. And at the bottom of this slide, you can see some pictures of the charging station. And this charging station can also charge aerial vehicle with 5 seats.
그게 아마 통상의 우리가 전기
So generally speaking,
충전 스테이션과는 다른 형태인데요.
this kind of charging station is different from
수직 이착력장
general electric charging station.
수직 이착력할 때 장애물 표면에
Since this is for the
낮춰서 별도
E
개발을 한
eVTOL.
시스템이 되겠습니다. 다음은 이제 플라이 컨트롤 시스템.
And next, let's move on to the flight control systems.
아마 뭐 보시다시피
As you can see,
인증 기준안과 시스템 스펙
I have already told you about the certifications, checks, and
부분들을 각각 보여주는 부분이고요.
these are how we have analyzed and did the checks for the compliance for FIDS, and also as for the we are also it also includes some descriptions for the reduced flight, and it also we have with Hanwha we have developed a related system. We have developed the hills, and we are doing the integrated test covering hills and others.
비행 제어 시스템
And
개발을 하기 위해서
as for the subscale test demonstrator,
초도 비행이 아까 설명드린
as I've
것처럼
said, our first flight for the subscale test demonstrator was completed in November 2020. This is 44% subscale. So as I've said, the full scale is 7 meters. So the span for this 44% OPAB is 3.1 meter. And the MTOW is 46 kilogram with battery with 2.1 kilowatt hour battery. We have conducted ground integration tests and also tethered flight test with power crane. We have we have tethered it to a crane. So the first flight was conducted at the Gohung Flight Center at early November in 2020. You can also check some of our footages on YouTube by typing Kari test demonstrator. And we have done full transition in June last year. I'd like to share a short video clip for full transition. You can decrease the volume. So these were early June last year. We did the autonomous takeoff and landing. This is a point navigation. As for the reduced, this is a reduced OPAP, so the communication can only reach to 10 kilometers of radius. So we can drive up to, we can fly up to around 50 kilometers. As you can see, we are speeding up. So the rear prop has stopped during cruise. There's no reason why we need to rotate the rear prop while cruising. As you can see, the rear prop and the front prop are arranged differently. So it's coming back. The rear prop, rear propeller are starting to rotate once again. It is auto hovering and it is also auto making auto landing. So we are currently developing. We were developing the auto landing routine back then. So as you can see, there has been a little bit of time slip, but for the time being, we have completely corrected the time slip problem during the auto landing procedure. So with this, I'd like to wrap up my presentation. Thank you so much for your attention. Let's give a big round of applause to Dr. Hwang. So Dr. Hwang has been involved in various kinds of demonstration and research projects for UAM aerial flights. As you saw in the brief footage, you saw some of the demonstration for reduced flights.
Let me invite the next presenter, Yu Chang-son. He will give you the presentation on the R&D program for civil UAS in Korea from KARI. Let us invite him to the podium with a big round of applause. Hello, everyone. I am Yu Chang-son from KARI. So my presentation will be about the R&D program for civil UAS in Korea. As for civil UAS, we have KIAST 100. This is used to be a small light aircraft, but we were transitioning into an unmanned UAS.
먼저 국제 기술 동향을 한번 살펴봤습니다.
Let's take a look at the international trend.
분야에서 기준 선도에 가는 기구는 이제 ICAO.
So ICAO is the
정책 제도
basic standard for standardization of civil UAS. So we are using ICAO's SARPs. First, licensing in Annex 1. That was announced back in 2018.
인증 관련된 에어워스니스 같으면 이제 안엑스 A 시승이었는데
And back in 2018, the draft for Annex 8 and Annex 10 was announced.
그래서 이걸 각국에서 시행을 하게 되는 건
So I think it would take time for countries to fully adopt it. So the full implementation is expected in 2023 or 2024. And in the meantime, various demonstration projects are being pursued. So KIAST 100
항공기로서 4인승 항공기가 개발이 됐고요.
was first developed for the certification purposes.
사업을 진행을 한 바 있습니다. 무인 항공기 쪽에서는 이제
In the UAV, until last year, operation safety was examined. So we are trying to develop the system for certification technologies, especially in terms of airworthiness. Depending on the altitude and the type of aircraft, we can categorize different aircrafts. Below 100 kilograms, 150 kilograms, and over 600 kilograms. And when you look at the altitude, there is 150 meter and 300 meter and 4.3 kilometers. And for this project, we are looking at the aircrafts of more than 600 kilograms and that can fly over 500 feet. Just like the OPOP project, our project has been implemented around the same time, and we've been pursuing for 5 years. It is also funded by MOLIT, and KC-100 is now being converted to the unmanned aircraft system for certification basis. So these are different entities involved in the project. Under MOLIT, there is KIAST and KARI. We are the supervising body of this project. There are 4 different sub-projects. First sub-project
flight control 시스템에 해당되는
is about the flight control system.
수행을 1과제 항공우주연구원이 수행을 하고
And that is being conducted by KARI. And KAI, which developed KS-100, is also involved in the second sub-project. And for the third sub-project, ground control system data links are being developed by StarTech. So at KIAST, they confirm the compliance of certification as part of the 4th sub-project. And their combined effort will build the necessary infrastructure for UAS in Korea. So these are key milestones. Since we're developing a new aircraft, so we have different phases. starting in 2019, conceptual design, preliminary detailed design, review, SRR, SDR. And back in 2020, we reviewed our preliminary design. Last year, October, we also conducted a critical design review. And based on the results, we fabricated the vehicle and we conducted the unit test. So there is the engineering part of this project, and there is this certification related project. There's flight control system, airframe, data link, ground control system. These are the involved elements or components of the project. Now we are in 2022, and this is February. So as of now, these individual components are being integrated into the UAS to be ready for ground test or flight test. So I think we will be starting the preparation for flight test as end of this year. Let me give you our R&D strategy. There are two categories. So there is KC-100. So based on this, we are building UAS and also developing compliance technologies. So if you're interested, this KC-100 small aircraft, it was a 4-passenger aircraft. And the development was done in 2013. Type and manufacture or production certification were obtained from MOLIT. Because of the COVID, there was some delays. So I believe we also obtained additional approval as well. We provided 25 aircraft to the Air Force Academy for pilot training. So now we have 2 for test and evaluation, 2 for prototype, and another one for certification. So let's take a look at the specifications. The length is around 8 meters. The width is like 11 meters. Maximum cruising speed is 389 km per hour. Maximum operating altitude is 7,620 meters. To add, in terms of our R&D strategy, this is the first aircraft that won the type certification. And to use this for compliance certification, we need a lot of different technologies. So we are going to use KAC-100 to use its already certified and approved elements and add specific or special components of UAS or UAV for UAS compliance. So we are building systems. Also, we are developing certification technologies. We also identify necessary standards, develop CCL or compliance checklist. In addition to certification basis. So there is the alignment between development and development of systems and development of certification technologies. So our research accumulate data, and infrastructure will be developed based on these.
이 인증기술 개발 내용은 또 내일 특별히 또 인증 및 산업 편전 동향 해갖고 9시에 항공안전기술에 대해서 무인 항공기 시범 인증
KIAST
발표가 있습니다. 그래서
will have another
잠시로 보시면 되겠고요.
presentation tomorrow at 9, so I think that will give you more detailed information about this.
수정되지 않은 거는 파스 23을 사용하고 그대로
So as for KC100 certification, we're going to just use the KS Part 23, but we are going to add special conditions
안엑스에 있는 것들로
due to some changes in the design to identify what is the necessary compliance technologies.
인증 관련 기술들의 이제 중요한 산출물 결과물이 되겠습니다.
So let's take a look at what are the key deliverables here.
시스템에 대한 인증 기준 이런 것들이 셋업이 안 돼 있는
We don't have any certification basis yet. They are in development.
서티스페이시스에 대해서 식별을 하고
So we are going to identify what kind of certification basis we need,
각종 활동을 하고 또 이제 인증
and additional validation activities will be done.
결과 보고서들이 3차년도, 5차년도에 각
And the third year and fourth year, we are going to also prepare some reports based on the activities so far.
컨옵스입니다.
Let's talk about CONOPS, or concept of operation.
무인 항공 시스템으로 개발된 비행체를 공에 있는 국가 종합 비행성능 시험장에서 시험을 하려고 합니다.
So we are going to test the aircraft we have for unmanned operation. We are going to use 2 GCSs. The data link will cover around like 50 kilometers, and that will be used to test the handover function. On the shore, we are going to conduct the monitoring.
운영하는 그런 이제 운영 개념이 되겠습니다. 지금 각 시스템별로 개발되고 있는
And these are components
설명을 좀
being developed for the system.
시스템 중에서 플라이 컨트롤 시스템,
First, flight control system.
데이터 링크,
And also, if you look beyond this, there is data link too
비행체와 지상
that will connect the ground equipment and the aircraft. And there are other very important devices for control. As for FCS, flight mode selectors, actuators are included, and surface control too, ADT, GDT,
비행 통제 장비들하고
and other controllers,
조정 장비하고
also controlling control modules, display.
인증 관점에서 시스템을 개발 이제 해야 되니까 병지역
Since we need to develop a flight control system for certification, due to the reliability issue, we of course went for redundancy.
다중화, 삼중화돼 있는 시스템이
So
되겠고
it's like not just redundancy, like triple redundant system.
입력 센서 눌러서 항법 센서하고 GPS
Navigation sensors, GPS, INS,
트랜스펀더,
transponders,
기준의 충돌 기능으로 사용하는 장비가 되었고요. GPS INS하고
GPS, INS.
항법 고도계 이런 것에 대한 항법 장비가 되겠습니다.
These are for the airborne navigation. They are triple redundancy. We are using actuators developed and manufactured in Korea. And we also have secure redundancy for aileron to elevator rudder and throttles.
그리고 캔 통신.
We also use CAN communications bus system.
네, 중요한 플라이 컨트롤 시스템의 소프트웨어 쪽입니다. 소프트웨어는
Let's take a look at the software side of the system.
FCC 하드웨어 안에 들어가는 비행 운영 프로그램인 OFP가 있겠고,
We have
그리고 이제
OFP,
비행으로 진행하기 위한 비행제어 소프트웨어가 있겠습니다.
flight control software.
개발 절차에 따라서 요구도가 있고 요구도
Different software programs are being developed according to the procedure.
로 개발을 하고 있습니다. 그 개발된 것을 오스코드 제너레이션을 해서
OSCO generator is used to run hills
검증을 통해서
and validate the software.
개발을 하고 있습니다.
That's how we've been doing it.
플라이트 컨트롤 시스템 항공우주연구원 1세부 쪽에서 수행한 2021년도 결과.
Back in 2020, this is the results for our flight control system development program.
비행 운영 모델을 들어간 파라미터를 저희가 다시 획득하기 위해서 비행 시험을 진행을.
We conducted a flight test to acquire necessary parameters.
비행 운영 모델에서 파라미터를 새로 업데이트를 해서
To update the parameters we have and develop a simulation scenario that looks a lot like the reality.
수행하고 있는 단계가 되겠습니다. 또 하나 이제 30% 크기의 이제 소형
We also have a third size KC-100 for flight test.
관련된 플라이트 컨트롤 시스템의 인증 관련된
These are the certification related activities.
2주에 한 번씩 정기적인
Every 2 weeks, we have a working group with relevant stakeholders to assess the progress of the sub-projects and define requirements so we can decide on the necessary components of the compliance. And then airframe, so modification of airframe. We have modified the KAC-100. We removed the seats,
각각의 항법 센서 그리고 비행제 컴퓨터
avionics, navigation, flight control systems, electronics, flight control computers were mounted on the airframe.
그래서 조립 공정이 되겠습니다.
This is the assembly flow.
밑에가 있는 게 이제 기존의 항공기 캐시를
So on your far left, that is the initial stage. We removed unnecessary parts for unmanned piloting, and then we added gradually the components for the unmanned flight. So we have developed different necessary components, and we are testing different systems. So soon they will be fully integrated into the airframe for test flight.
비행체 중에서 각각의 그 작동기 클러치
Actuators, clutches.
액추에이터 시스템들이 이중화되어 있어서
So actuator systems have redundancy, and then clutches were used for additional layer of redundancy. That means like triple redundancy. And we also made an iron bird for testing. As for the electric systems, we also added a flight control computer.
SU와 실 이런 장비를 통해서 시험 평가 중에 있습니다.
So we are using seal for testing, and we also added wire harness.
마찬가지로 이제 인증 관련된 비행체 개조 부분에 인증 관련된 항목들 식별.
So for the certification basis, we check what we are going to need for certification when it comes to modification of the airframe. Then ground control system is also have redundancy. C-link EHF data link, GCS data shelter will have it all to support communications. They are all integrated into a single system. There are consoles for control the flight. Of course, there is a HVAC like air conditioner.
네, 그라운드 컨트롤 시스템에 미션 컨트롤 쪽하고
And it shows two consoles, mission console and pilot console, and different elements for the system, and they are also now being tested.
네, 데이터 링크 쪽에
As for data link, it is also redundant. We are using very high radio frequency.
개발되어 있고 각각의
We have terminals, and different components have been tested or expecting trials.
네, 인증 관련되었고 이제 그 사세부에서 수행한 부분인데
So that is the certification basis we have identified from the fourth sub-project, but the details will be explained tomorrow's presentation. This is the report on the compliance basis for small unmanned aerial vehicle system.
사업을 통해서는 이제 운항공 시스템이 앞으로 무인기가 활용이 이제 무궁무진해서
So UAS have unlimited applications. There will be growing demand in the market. To truly commercialize it, before that we need the certification. But the industry standards for certification have not been fully established yet. So now we are leading the effort to develop the standards and also necessary systems. And through this development, we are going to use the proven technologies for compliance. So these are these will be very important deliverables from this project. That's all for my presentation. So I also have a video to play. Can you play for me?
공항공센터에서 작년에 10월달에
This is the test flight from last year. I think it was in October. It runs in the middle of the runway and takes off automatically.
사전에 계획된 임무 프로파일 따라서
Following the pre-programmed mission profile, the aircraft flew. So it was automatic landing, automatic taxiing, automatic taking off. That was the three main goals of this trial.
축소기로 배행하게 된 거는 이제 KC-100이 갖고 있는
So KAST 100 has its own characteristics with this landing gear.
좌우 랜딩 기어에 차동 브레이크를 통해 갖고 이제
They have different brakes on its left and on its right to decide or control the direction of landing. So when we were developing this aircraft,
진행될 수 있을지 보는 거 하고
we wanted to make sure the control is done right in terms of landing. Vertical landing is for fixed wing, I guess. And the angle should be also considered like altitude.
자동 착륙이 이제 원활히 이루어질 수 있는
So these factors should be considered to make sure vertical landing. So we wanted to test it out with a smaller, like scaled down version.
착륙하기 전에 네 포인트로 이제 착륙 지점들을 설정을 해놨고요. 그 지점들 지나가
We had 3 different landing points to see how this machine responds to it. Between 3 to 5 degrees angle, the plane landed on the ground.
약간 측풍이 있을 때 이제 크랩 비행할 수 있는 그런 기능도 들어 있고요. 예, 발표는 여기까지.
So that's all for my presentation.
발표를 들어주셔서 감사드립니다.
Thank you for listening.
네, 발표해 주신 유창선 대장님 정말 감사합니다.
Thank you, Mr. Yu, for your presentation for the application and commercialization of UAM. The certification is very important. I will look forward to your continued effort. And let me introduce you the next speaker.
So at the moment, over 300 people are joining us online via YouTube. If you have any questions or comments, please leave your questions in the comment section on the YouTube, or you can also leave them on the Eventus channel. So I'd like to invite our next speaker. Our next speaker will be Dr. Rob Weaver of Eve Air Mobility. He's joining us online from abroad.
Good afternoon.
He will give us an overview of Eve's National UAM Ecosystem Research and Development Project. Dr. Rob Weaver, can you hear us?
Hello, everybody. It's good to be with you today. I will
Yes.
just share my screen now.
Yeah, please go ahead.
Thank you very much. Thank you very much for the invite to come and talk today. I have very much enjoyed listening to the meeting so far and hearing about all the success of progress towards this exciting new industry in Korea. I am talking to you today from Singapore as I'm here for the air show, but I normally live in Australia, and I hope to be able to join you soon and come visit you in Korea. Today, I will talk about 2 projects that Eve have led over the last few years, working with national authorities, research and development activities to support the future AAM industry. To tell you a bit about myself, I am the global lead for regulation and public policy for Eve, and I've been working with Embraer X and now Eve for about 3 years. Before this, I was head of safety for air traffic control in Australia, and I have spent most of my career working in air traffic management. And so what I will talk about today is some of the air traffic management implications of this new industry, urban air mobility. Before I talk about the projects, I will do some introduction for Eve, because I am not assuming that everybody has heard of Eve Air Mobility. So I will start by introducing Eve. Eve is the first spin-out company from Embraer X. Embraer X is the innovation arm or the innovation department of Embraer. And for those that have not heard of Embraer, Embraer is the 3rd largest commercial aircraft manufacturer in the world. They also produce corporate jets, and they also produce some military aircraft as well. And so Eve has a very good history and pedigree with respect to aviation. Embraer has a large amount of experience in certifying aircraft, and from that, Eve has been developed to build an eVTOL for the UAM industry. As well as our vehicle, and I will show you on the next slide a picture of our vehicle, but as well as our vehicle, we are also developing urban air traffic management software solutions, UATM, to support the future industry. And this is the work that I will talk about today. Eve's work on eVTOLs and UATM has been in development in Embraer X for 4 years and now is part of Eve Air Mobility. There is lots of really good information available on Eve's website, including details of our very large order book, which includes 1,735 aircraft sales to 17 customers. As was discussed this morning, we see the market for urban air mobility as very large, and Eve intend to be a large player within that market, supported by Embraer and its experience in aircraft development and certification. Interestingly, as well as developing aircraft, Embraer have a subsidiary that develop air traffic management systems as well. So the Embraer subsidiary ATEC provide the ATM system for the Brazilian Air Traffic Control Agency, DSEA. And this is some of the reason for their interest in the air traffic management side of urban air mobility. But before I go on and talk more about UATM, urban air traffic management, I will just show you some details about our vehicle. This is a picture of our vehicle, which has been in development for quite some period of time. Firstly, like most other eVTOLs, it is 100% electric, and so the utilization of it is zero emissions locally when we fly. Again, one of the good things about this industry is that we intend our vehicles to be quiet and have a lower noise footprint compared to helicopters. And for our vehicle design, this will be particularly true in the cruise phase of flight, where we used wing-based lift. We have put a lot of effort into thinking about how people can use the aircraft, and we have used a human-centered design approach to make sure the cabin can be accessible by all types of passenger. And equally, we have put a lot of thought into making sure that the design of the vehicle is both simple and reliable. So we want to make sure that the cost associated with the vehicle in terms of certification and ongoing maintenance is low. Our vehicle will be piloted at first, and we expect to operate the vehicle as a piloted VFR aircraft. But it is going to be ready for autonomy. And in the future, we hope to be able to fly the vehicle autonomously with passengers. Our focus is on urban air mobility. So we are looking at missions in the 60-mile range, and we think our solution covers nearly all of those targeted missions based upon our design. And like we have heard this morning, we expect this to be available to more people at a more efficient cost in the future. So as well as building a vehicle, we are doing a number of other things as Eve as well. So we are also looking to operate aircraft with partners and jointly operating those aircraft in different places in the world. We are also going to utilize Embraer's maintenance, support and training network to provide services for Eve and other types of vehicle around the world, using our experience in services and support and training. And then finally, what I will spend most of our time talking about today, we are developing solutions to support the air traffic management of urban air mobility. So looking at growing our knowledge on urban air mobility, we've been working for a number of years to look at how these aircraft can operate safely in our skies with all the other types of aircraft that operate in the skies at the same time. 3 years ago, we published our Flight Plan 2030, and at that time, not many people were talking about the air traffic management of urban air mobility. And what we believe is that a new approach is needed to manage these aircraft in the future. And we think the current ATM system will not manage the complexity of the airspace as these aircraft scale in number and operations grow. Equally, we don't think that drone traffic management or UAS traffic management systems will be able to manage piloted passenger carrying aircraft. And so we proposed a new approach that we call urban air traffic management, and we proposed that in 2019. In 2020, we worked with Australia's air navigation service provider, Air Services Australia, to publish a concept of operations for urban air traffic management. And this document that you can see on the slide is available to download and freely available for everyone to read. And I will talk a bit more about that document in a minute. Last year, we worked with the United Kingdom's Civil Aviation Authority, the UKCAA, with a consortium of other urban air mobility partners to build a concept of operations for London and how to operate aircraft in London. And again, I will talk more about this in my talk today. Now we are moving on to doing more ecosystem development work and concept of operations in Asia Pacific, North America, South America, and we also plan to start demonstrating our software that we have developed to manage UAM air traffic this year. So we are working globally with governments, air navigation service providers, regulators, the AAM industry and stakeholders, and the traditional aviation industry, because we believe all these parties need to come together for us to be able to develop this new future. So when we think about this future that people have been discussing today, we need to think about the network of operations that will be needed to support the future services that we would like to offer. In the future, we will see much higher tempo, density and complexity of operations. The number of operators in the urban environment will increase significantly, and there will be multiple different vehicles with multiple different operations occurring at the same time. As has been discussed already today, these vehicles, eVTOLs, will have unique performance characteristics. How they will behave will be different to traditional aviation. And one of the greatest challenges is the energy usage that's needed and ensuring that that is minimized to enable the flights to be efficient. We expect in the same time to see both more UAM aircraft, more eVTOLs, and more drones operating UAS aircraft operating in the urban airspace. Challenge around integrating drones, eVTOLs, and traditional airspace users, so helicopters, general aviation, in some countries hot air balloons as well, into the same airspace is a really complex issue. Another factor that we need to consider is how vertiports are used and enabling short turnaround times that occur at short notice, and where we need to be able to guarantee that the aircraft can land, charge, and take off when it needs to, for when the pilot and the passenger need to use the aircraft and the vertiport. We've done a lot of work with current helicopter operators, current air mobility operators, to understand how their operations work today. And what we see is some real challenges in how we might be able to work things in the future. So firstly, they use multiple data sources. There is not the integration of the information and the decision support capabilities to manage flight operations. There is a lot of challenges of manual data entry and not much automation for how helicopter operations and air mobility work today. And a lot of the systems that are used are not integrated, they're isolated, and there isn't good communication and coordination amongst the air mobility stakeholders. So we need to find a new way to manage this network, to manage the information sharing that has to occur across multiple operators, multiple vertiport operators, the air navigation service provider, and all other users of the system to understand how things will work safely. So in 2020, we developed a concept of operations with Air Services Australia to look at this challenge and look at a new way of managing air traffic in the urban environment. And what we used is the ICAO key performance areas that apply to air traffic management around the world. So there are 11 key performance areas on this slide, and each of them will be important when it comes to managing traffic in the urban environment. Firstly, safety. So aviation has a fantastic safety record to date, and it will be very important for urban air mobility, carrying passengers, to achieve a similar or even better safety performance compared to traditional aviation. Similarly, security will remain extremely important, and we want to know that threats to aircraft operations can be managed effectively. As we've heard about, aircraft noise will be really important, and other environmental considerations such as the efficiency of the flight and how much fuel or how much energy is used as part of the flight will be important to consider. In terms of air traffic management, the cost of the systems that support the operations needs to be carefully managed. It cannot be too expensive to provide air traffic management solutions to support operations, otherwise the industry will not be successful. And the air traffic management solution for the urban environment needs to manage a capacity far beyond what capacity is currently enabled through ATM in the urban environment at the moment. We also need to make sure that the flights are as efficient as possible. The batteries that the aircraft will use to power their flight will only have limited reserves, and so we need to make sure that holding in the air is limited and aircraft can arrive at their destination in an efficient manner. We also need to have a system that is flexible. At times there may be a reason for a vertiport to become inaccessible due to an airspace constraint or because the vertiport becomes unavailable for some reason. So we need an air traffic management system that's flexible, that enables an aircraft to fly to an alternate vertiport when required for various reasons. We need our air traffic management approach to be predictable. We need to know that when the flight is booked by the passenger and then when the fleet operator book the flight, that the service can occur. We need to know and have some levels of guarantee that when services are booked by the customers, they can fly in the urban airspace. And we have to make sure that the airspace is accessible for all airspace users. So we need to make sure that different fleet operators can operate in the airspace, but also other types of aircraft as well, be that general aviation, helicopters, and as I said, as an example, even hot air balloons. How we make sure the airspace can be accessed and used by all different airspace users is a really key challenge for urban air mobility. We need to make sure that the air traffic management system allows all contributors to the urban environment and the airspace that is used to participate in that and collaborate in an effective solution. And then finally, we need to make sure that the approaches we take are globally interoperable. Aircraft that are developed will likely be used in many places around the world, and the traffic management systems need to support operations in many different parts of the world as well. So our work with Air Services focused on these 11 key performance areas and defining a concept of operation around supporting operations using these considerations. We worked with air traffic controllers, procedure designers, safety specialists, and regulatory and policy specialists as well. And as I say, this work is available to review. But I will play a video now that provides an introduction to our concept for urban air traffic management.
Electric vertical takeoff and landing vehicles, or eVTOLs, will soon transform urban air mobility. We'll rely on eVTOLs to get us to our destinations on a daily basis. Commercial aviation has an enviable safety record, and we will expect this same high standard of safety for urban flights. But today's air traffic control system wasn't designed for high volumes of low-altitude intracity traffic. Unless we have a system that manages high traffic volumes safely, the growth of urban air mobility will be limited. New New concepts such as Unmanned Aircraft Systems Traffic Management, or UTM, show great potential, but they don't address the unique safety and operational needs of piloted passenger-carrying flights that rely on voice-based communication. We've developed a concept called Urban Air Traffic Management, or UATM, to ensure the safe scalability of urban air mobility. UATM proposes a centralized system for managing urban air traffic that also exchanges information with ATM and UAS service suppliers. As demand for urban air mobility grows, UATM will mitigate safety risks, reduce demands on air traffic control, ensure equitable airspace access, and adapt as aircraft evolve from piloted voice-based flights towards autonomy. UATM is built on two foundational services: airspace and procedure design, and information exchange. These foundational services ensure a harmonized approach to integrating all airspace users, including conventional aircraft and unmanned aircraft systems. To support daily traffic management needs, UATM provides 4 operational services: flight authorization, flow management, dynamic airspace management, and conformance monitoring. We are working with air navigation service providers, government and industry to tailor UATM solutions for their communities. Together, we are preparing for the future of urban flight.
Okay, so I hope from that video you get some idea of some of the challenges we see with operating in the urban environments, where we have to manage the integration with traditional airspace users and with drones, and manage the fact that these aircraft will start as most likely piloted passenger carrying aircraft that operate under visual flight rules, but eventually evolve towards remotely piloted and eventually autonomous aircraft. And so we believe a new construct, a new concept is needed for the entire urban airspace, where all users of that airspace are able to be integrated into one traffic management system. So this was the work we did in 2020 with Air Services Australia, and it was a very successful project. We enjoyed engaging with the air navigation service provider, and we had really good feedback on that work. In 2021, after that work, we went on to work in the UK with a consortium that we put together. Led by Eve, we involved NATS, who is the UK air navigation service provider, Heathrow Airport, London City Airport, Skyports, who we'll hear from in the next presentation, but Skyport's the vertiport development company, and importantly, other OEMs, other aircraft manufacturers in UAM, to ensure that we had a holistic consideration of the issues. So we invited Vertical Aerospace and Volocopter to be part of this project. And the last consortium member was ATEC, who are the subsidiary of Embraer that build the air traffic management system for Brazil. So we pulled together this consortium and we worked with the United Kingdom's Civil Aviation Authority, the UK CAA, to develop a concept of operations to integrate UAM aircraft into London. How would that work with current airspace? How will we look at designing the airspace and the routes to enable the integration with current operations? As part of this project, we also looked at stakeholder education and engagement to validate and promote the benefits of urban air mobility. And we looked at how we would organise a use case to transport people from London City Airport to Heathrow Airport with some stops in between those two airports, London City and Heathrow being on either side of London. As part of the project, we also did some simulation and modelling because we wanted to validate some of the concepts and ideas. And we worked closely with the UK CAA on the work, and they provided significant feedback. And details of this project are available online at the ukairmobility.com website. And we hope very soon to publish the final results of this project, hopefully within a few months. And it'll be good to be able to share that with people. But prior to our final publication, the UK CAA has already gone ahead and published a CAP document, as they call them, CAP 2272, which is based upon the work that we did on the London concept of operations. That document looks at some of the key considerations for airspace integration within an urban air mobility landscape. So this is a first document of its kind that is trying to spell out what are the challenges, particularly regulatory challenges for airspace integration to achieve UAM sustainability, to achieve the UAM business case. It was great to see this work published, and it's available through the link shown at the bottom of the slide. And we will be very interested to receive feedback on this, as well as the Air Services Australia ConOps, and then eventually when we publish the concept of operations for London as well. So thinking about these projects that we've done around the world, and I should mention we have done other projects around the world as well. We have also done simulated passenger journeys, looking at how people would fly using helicopters. And we have also done consideration of passenger experiences and eVTOL and passenger user journeys to prepare for UAM implementation. If we look at a number of these projects we've done around the world, what we think is really important is that the ecosystem that is developed to support UAM needs to be agnostic. It needs to be able to work for a variety of different airspace users and aircraft types and operators. It needs to be integrated. So it needs to allow operations to integrate with urban air mobility operations, ground operations, other airspace operations. And it needs to be equitable to allow all members of the ecosystem and all members of the airspace to participate to the greatest extent. If we don't achieve this, we won't allow the industry to scale, and we won't get the community support and industry acceptance. And so we'll continue to work on these subjects with governments and industry over the next few years, and we'll be very keen to work with people in Korea on this as well. We find the best work we do is when we partner with other organizations. And so I give you just two examples here. We have partnered globally with Skyports and done a number of projects with them to explore the ecosystem. And another example from the Asia Pacific is we've have a collaboration with Ascent, where we have an agreement to provide 100,000 hours of flight time per year across Asia Pacific. And so to conclude, we are now looking to who we may be able to partner with in Korea, because we're interested in developing concepts, systems and services across our product portfolio in Korea with Korean organizations. And so I hope I can come and visit Korea very soon, and we look to partner with people in the future. Thank you very much for your time.
네, 발표해 주신 롭 위버 박사님께 큰 박수.
Thank you so much. Please give a big round of applause to Dr. Rob Weaver. Well, in Korea, there are many companies involved in UAM field, and I believe there are various kinds of activities that are done by overseas operators and companies. So Eve is looking for Korean partners in Korea as well. I hope you can find them here.
Next is about vertiports, which is a very important infrastructure piece for UAM. So we will invite Hwang Li Hui, and she's also joining us virtually, so she will join us on the screen. Hello.
Hi everyone, good afternoon to all. I'm Li Hui from Skyports, and I'm part of the APEC team located in Singapore. So I'm very excited here today to share on our design approach and projects for advanced air mobility. And before I begin, a huge thanks to Rob for your shout out earlier. So I'll move on, and I think to begin, I'll take a step back and look at the problem that AAM is solving. So this problem is clear. Today we see 56% of the world's population living in cities, and we see an estimated 9 million deaths estimated per year from air pollution. And from an economic perspective, an estimated $88 billion is lost to congestion in the US. And if we try to solve this problem by building more roads, this comes at a cost as well. And more importantly, this is not a sustainable solution. So the only solution that I think we are all here today that we are looking at is advanced air mobility. And billions of dollars have been invested by eVTOL OEMs, with the first vehicles expected to be certified in the next 2 years. And the AAM solution provides fast transportation with speeds of up to 300 kilometers per hour, safety through distributed electric propulsion technology, and cost effectiveness. And above all, it is also environmentally sustainable and quiet. So while the OEMs like our friends at Eve are pushing ahead through certification, we also need to keep our eyes on another critical aspect of the ecosystem, which is the landing infrastructure, also known as the vertiport, which is required to serve and support any air passenger or cargo drone flights. And this is where Skyports comes in. So at Skyports, we are a mobility company that develops and operates landing infrastructure for electric air taxis and cargo drones. We are headquartered in London with regional offices in Singapore, which is where I am in, and Boston. Our investors include major players in the mobility space, such as Deutsche Bahn, which is the National Railway of Germany, and Group ADP, a major airport operator based in France, Islandia Aviation, the family office of Ryanair, and Levitate Capital, which is a major venture capital firm focused on next generation aerial mobility, among others. So at Skyports, we manage the entire process of vertiport development from design through to development and operations. And we work closely with key local partners, including landlords, building owners, governments, throughout the entire process. So before we go further into the presentation, we should also have a quick view of what a vertiport could look like. And the rendered image shown on this slide showcases a simplified vase vertiport design involving one final approach and takeoff pad, 3 eVTOL stands, and a simple terminal. At Skyports, we focus on first, having a vehicle-agnostic airside design that is able to accommodate any OEM's eVTOL. Second, a terminal with high passenger throughput that is able to process passengers efficiently and with minimum building footprint. And third, based on next-generation traffic management systems. Fourth, with dedicated re-energization facilities and that is flexible enough to cater for different OEM needs, whether it is through charging at the stands or battery swapping. And fifth, we design based on the emerging regulatory framework. The Skyports works closely with aviation authorities to align our designs under development to the latest guidelines. And this is where our focus on even the smallest details of important components, from concept for operations through to things like airfield markings and security, come into play. So besides air passenger taxis, we are also looking into design and development of cargo drone pods. And such drone pods will enable both ship-to-shore deliveries and also regional opportunities. And with regional opportunities, we will look to enable cross-border cargo drone deliveries. And the design here will need to cater for different VTOL pads to address both smaller and larger drones on the market. And to enable the full chain of goods movement, warehousing facilities and potentially cold chain facilities will need to be considered as part of our planning for any future cargo drone pod. The design approach taken by Skyports can be summarized through our 9 design pillars. And you have already heard about our OEM agnostic approach. So besides that, we also strive to establish a site agnostic based design that will allow us to bring a strong design base to any location in the world. But we are also always keenly plugged into the local context and will ensure that all designs are adapted to meet the local conditions and environment. So next, a scalable design is also key to our design approach. Vertiports need to be able to cater for new requirements of all future business needs. For example, customs and immigration facilities may need to be added once regional flights across borders can happen. And as the passenger demand builds up for vertiports, we may also need to expand the vertiport on site. And hence, the scalable design allows us to balance between building vertiports today while safeguarding potential for future operational requirements and to minimize the cost and risk incurred today. A big part of enabling scalable design is thus to have a modular design approach. And a vertiport that is modular and designed for manufacturing and assembly can also be more rapidly deployed. And this is important because we can then design and manufacture the vertiport off-site in a controlled environment before assembling it on-site. And this helps us to operate in highly urbanized environments such as downtown Seoul or in Singapore, where land is prime and limited, and impact to existing stakeholders within the area needs to be minimized. A fifth design pillar of skyports is also to be regulatory compliant, and above all else, our vertiport designs are based on the latest guidance from EASA and other aviation bodies. And where guidance is not set yet, we take educated references from helicopter guidelines and study the suitable technical approach, drawing on our in-depth knowledge and discussions with OEMs and suppliers. And in line with our regulatory compliance, our design is also highly functional, and we prioritize function with the practical mindset that the vertiport must work efficiently and effectively. A seventh pillar for skyports is sustainable design. This is since sustainability is key to AAM, and our design will reflect this through energy efficiency and zero carbon initiatives. An eighth pillar is that the design must be cost effective, and the overall commercial proposal for the vertiport must make sense for all stakeholders involved. And last but not least, the vertiport design must be visually attractive, as vertiports will eventually form part of any city's iconic urban skyline. So I've gone through our design pillars, and these are accompanied by drivers for vertiport requirements. So vertiport requirements include customer experience touch points, and we consider every customer's passenger touch point at each step of their journey in planning a vertiport. We then look at what are the activities required to process the passengers at each point. And we establish the minimum facilities required for a passenger to safely complete their journey at our vertiport. And importantly, we establish the requirements to ensure a safe and efficient interface between the terminal and the airfield. So to sum up our design approach, we strongly recognize the need to go beyond futuristic drawings for vertiport designs, and airport planning expertise must be applied across all components of a vertiport, from surface access through to security. And at each step, Skyports evaluates the design trade-offs, such as reducing visual attractiveness to reduce upfront costs, or accepting a higher operational cost for regulatory compliance. And this practical, nuanced, and comprehensive design approach forms the core of how we approach vertiport design at Skyports. And the design must, of course, be tested. So I move on to a few of the projects that we are now working on at Skyports. The first project that I would like to share is our test-bed vertiport at Sergi-Pontoise. We are working with Group ADP, one of our investors, to develop the first vertiport testbed at Sergi-Pontoise airfield near Paris. And through this testbed, we will test out technology, systems, and operations for passenger terminal, airside operations, and airspace integration. This testbed project will be key to enable AAM commercial operations by 2024 in France. And vertiport development is planned for the first half of this year, with testing and demonstration planned for later this year. While this project is not in Asia Pacific, I have mentioned it here because the work that is done at Sergi-Pontoise, the testing done here, and the learnings will feed into the work that we are doing in Asia Pacific and vice versa. And at Skyports, we have numerous projects running at different speeds and timelines, and we are actively identifying where the testing or demonstration work from one regional project can speed up the work of another elsewhere. Shifting the focus to APAC, we have partnered with Japanese conglomerate to deploy the vertiport sites in Osaka in time for Japan Expo 2025. We are a member of the Osaka Roundtable for AAM and are supporting the Government Research Institute NIDO. And currently, we are also in discussions with major landlords in Osaka to secure sites for vertiport development. Drawing the focus to Singapore, where I am at, we continue to target to build the first commercial passenger vertiport in APEC. In 2019, we designed and built the world's first vertiport prototype together with our partner, Volocopter. This was the first ever urban trial conducted over Marina Bay, and we maintained a strong partnership with Volocopter in Singapore. At the moment, we are in active ongoing study with the Singapore government to develop a commercial vertiport in the next 2 to 3 years. And still in Singapore, and not forgetting, our drone services are also progressing rapidly. We are currently conducting surveillance of reservoirs for Singapore's government body, the Public Utilities Board. And currently, we are also conducting trials to fly drones to deliver high-value goods between shore and ship in Singapore's anchorages, which is one of the world's busiest waterways. And just yesterday, we also announced that we have formed a consortium with ST Engineering and Sumitomo Corporation to use unmanned aircraft to deliver goods from shore to ship in Singapore. This gives a major boost to the trials that we have been conducting in Singapore. We have also taken up space at Seletar Aerospace Park in Singapore and is planning to set up a drone operations center there. We will then be able to conduct beyond visual line of sight drone flights in APEC from our Singapore office. And for this piece of work, we are targeting substantial scale up and rollout in 2022. So to conclude, we have numerous projects coming up in APEC and around the world, and these projects require collaboration with technical institutions and authorities. We are ramping up on our vertiport deployment work as we anticipate certification of the eVTOLs and upcoming technology maturity of batteries and UTM systems. We also see harmonization of emerging international framework and standards as the key step for commercialization of vertiports in the next few years. And this is something that Skyports is working hard on with aviation bodies. As we work on our APEC projects and apply the standards, we will also work with government and technical authorities to jointly refine these standards. And lastly, as we work towards commercialization of vertiports, we also see a great need to work with governments and technical partners to conduct public demonstrations, showcases, and outreach to garner greater social acceptance. So with that, I come to the end. Thank you for your attention. And at Skyports, we are always on the lookout for more collaboration opportunities in Korea and in the wider APEC. And please reach out to me if you have any queries or opportunities.
네, 발표를 해주신 황리 후인님께 감사.
Please give her a big round of applause for amazing presentation. For the commercialization of UAM mobility, not just development of the aircraft, but also the development of infrastructure is very important. The design and related activities are well described, and thank you for your presentation. I look forward to your future advances.
From now on, we will have a Q&A session with speakers from the session 2.
이제 무대로 모시고.
So for the Q&A session for session 2, I'd like to invite all our wonderful speakers who have joined us here on site. Please come to the front stage, and I'd like to ask all speakers overseas to join us online for the Q&A session. And I'd like to invite our moderator, Professor Lee Dong-gyu of the Korean National University of Transportation, or KNUT. Professor Lee is also serving as an advisor to the Korean Air UAM Association. Please welcome him with big round of applause. Nice to meet you all. My name is Lee Dong-gyu. I'm from the Korean National University of Transportation. So for this session, we'd like to take up some questions with the speakers from the session 2 before taking some questions from the audience.
질문을 몇 가지 준비했는데요.
On the spot, We will ask some pre-collected questions to our speakers.
항공안전기술원 권태환 연구님께 질문.
So my first question goes to Mr. Kwon Tae-hwa from KIAST. So this is the second UAM demonstration project following last year and 2020. As it is a demonstration of the new concept aircraft, it is expected that there are many concerns. Please tell us about what you focused on the most and what was the most difficult task for you last year.
네, 안녕하세요. 항공안전기술원.
So hello, my name is Kwon Tae-yeon I'm from KIAST. So we had the demonstration for the flight operation.
항공기의 비행을 보여드릴.
For the eVTOL, we had this demonstration project for all people to see it with their own eyes. That's an important part. And what's also important is that what's most important when the UAM takes off and when it cruises and fly over the sky, what's most important item is safety. So
방지할 수 있는 안전이라고 할 수 있습니다.
Safety is the key issue. We need to eliminate all possibilities for any kind of accident. So so that is why we need to think ahead the potential accidents that could happen while flying UAM for our demonstration.
한 가지 질문 저희가 더 준비했습니다.
And we have one more question for you. Many entities in Korea are preparing for UAM service or demonstration. As an experienced expert, what kind of advice can you give? What kind of advice would you like to emphasize the most? So while carrying out the UAM demonstration project, I'd like to thank all the public for your strong support and interest. So receiving and gaining public acceptance is one of the most important factors in carrying out UAM project. Well, these are some of the physical achievements that we have made. So while we were doing this demonstration last year, we were able to verify the successful operation of UAM flight in densely populated regions. So through this kind of demonstration, it is important to set your goal, what you need to achieve through this kind of demonstration projects. Next, I'd like to invite Mr. Hwang from KARI. It seems that OPAB Research Center is successfully developing a prototype and infrastructure. Please tell us about the factors that made it possible to proceed smoothly with the project to develop this whole new aerial vehicle, eVTOL, in a short period of time. Thank you for your question. Well, I'd like to add something. Thank you so much for inviting me to introduce our OPAB project.
역시 이게 오파브
Once again, this OPAB has tilting technologies and it is powered by electricity. So this is a whole new concept of transportation. So without the knowledge of this kind of technology, it might be a little bit difficult to approach to this new kind of vehicle. So the vector thrust and the tilted eVTOL models can be out there. So without having that kind of technology, it is impossible to develop this kind of eVTOL vehicle. So in some cases, some models are this kind of eVTOL models. On the other hand, we have this OPAB model. For this OPAB, we have very advanced technology, and as I've said, it's enabled by tilted and vectored thrust technologies. So, as you said, we were able to quickly push forward with this kind of this OPAB project. So, since 2002, we were able to develop this tilt technology. So I believe that we were the second in the world to apply this tilt technology to the UAV, about 1 ton. And that kind of technology helped us to start with this new type of OPAB vehicle. And secondly, we were able to work with very good partners such as KAI, Hyundai Motors, Hanwha Systems. These are all the top-notch companies representing advanced Korean technologies. So all these helped us to quickly develop this OPAB project.
저희 한 가지 질문 더 질문했습니다.
So I have one more question for Mr. Hwang. So you mentioned that OPAB research was started in 2018 in Korea. Today, the eVTOL and UAM concepts are very popular among people, but they weren't back then. So it must be a challenging task. What was the greatest challenge that you have faced while conducting this research? You have already mentioned the vector thrust technologies. And while I was looking at the video, you had a successful transition flight. So how can this kind of research contribute to the domestic UAM industry? So this OPAB, we started this OPAB project back in April 2018. Well, we had this kind of opportunity at the late 2016. Back then, this lingo, such as UAM, wasn't that popular around the world. There were a few people who were interested in drone taxi or PAV or PAV projects. So we had maybe two kind of opportunities for review for this kind of projects. So to give you more of the background, one of the largest market for UAM operation is taxi service. And back then I explained to the review committee, about the taxi services. But one of the reviewer was kind of making a joke. Who would be interested in this taxi service? So we had the kind of challenges and difficulties along the way. But we overcame those kind of challenges. I believe this OPAB project is probably the first national project in Korea which received a national support for a new this eVTOL project. So we are trying to commercialize this OPAB vehicle, starting from single seat to 2 seat to up to 5 seats. So to do that, the propulsion system is really important, and the safety is also important. And so, as I mentioned before, for this OPAB project, we have secured these two core technologies. So we were able to successfully push forward with our projects. And also the compliance checks, certification processes are also challenging processes as well. While carrying out a great BASA project, we looked into the structures, and we have technologies to verify the structures for the models. But for this electric-powered vehicle and fly-by-wire battery and transition technologies, we don't have those kind of technologies for compliance checks. So I believe
그대로 활용될 수 있다라고 생각을 합니다.
I believe that the research results that we have over time will be of great help to those in the industry in the future. Next, I'd like to invite Mr. Yu Chang-sun from KARI.
특히 이제 유용성들이 많이 이제 가시화되면서
With the advance of the unmanned aircraft system era, many research projects are being conducted nationwide. So I've been seeing many different projects here in Korea too.
책임으로 수행하고 계신 본 연구 과제가 그간 우리나라에서 수행되었던 과제들이
So can you tell us the unmanned aircraft system project you've been involved in, like how different were they from the ones that were conducted before? So when you look at these projects, fixed-wing aircrafts, firefighter jets, drones, unmanned aircrafts, there has been many developments going on. OPAP, tilted rotary aircrafts, and also many others. So we've been considering different factors in the earlier stage, but for civil UAM, it's been a bit different. For the commercialization of UAS, we need to get type certification, operation approval, and many other certifications. But I think by 2023, our 4C KIAST 100 project will be utilized. But UAS, there is no international obligation requirements to obtain a type certification. There are no clear guidelines for certification.
그래서 그거를 이제 아이카오 중심으로 해서 이제 개발하자.
So KARI wants to take a central role in developing such necessary regulations or requirements. I think it is high time for us to take a look at the international trends in terms of the certification standards. So this project will utilize the existing guidelines for manned aircrafts, and based on it, we are going to add necessary factors to come up with our own infrastructure and criteria or rules for certification. As I explained, we had conducted research to convert manned aircraft to unmanned aircraft. And we are going to look at it from the safety perspective and certification perspective. I think this is what sets it apart. So I think this is a continuation of my previous question. So as you know, military unmanned aircraft systems such as surveillance and attack are quite popular, like for reconnaissance. However, in the private sector, it is being used for limited purposes like recreation, photography, agriculture, maybe some personal uses too. So I've been thinking about it too, but there has been some technical barriers because we need to use it in areas where population is not really too dense. So what are the barriers, like technical or social barriers, we need to overcome to increase the applications? So when you look at this from the perspective of certification, as you just said, we need to look at it from the safety perspective. There have been a lot of drone-related research activities, and some argue that we need to approve more active utilization of drones. But we still need to avoid the densely populated areas or flying drones at night for safety purposes. So I think proper regulations are being developed for drones, and for large UAS that weighs over than 200 kilograms, we need to take a more careful approach. Although it provides amazing performance and it can fly just like a manned aircraft, we still need to develop a master plan, and we actually have it. So we are going to suggest a roadmap by 2023. So, for example, detect and avoid. So if we want to fly it over a high population area, there are many things required first. Technological requirements that are being studied internationally or also in Korea should be examined further for their actual application. Let's move on to the next presenter, Dr. Rob Weaver. So this is my first question. Eve seems to be aiming to become a total service provider in all fields of UAM, from aircraft to operation and traffic management. So, as you know, for actual service, it seems that an international harmonization is needed for the same level of service and safety in many different fields, from infrastructure to systems to aircraft. So what is Eve's global strategy for providing UAM services to various countries?
Thanks for the question. I think this is a really good question. It's really important that the systems that support UAM aircraft and fleet operations are internationally harmonized. So that applies to the ground infrastructure, like companies like Skyports, where we would look to ideally have common vertiport design standards so that globally industry can expect the same kind of vertiport. And the same is true for the air traffic management systems. It will be the best course of action is to have a global approach, a globally harmonized approach to the information exchange systems that we use, so that the aircraft that operate internationally from lots of different companies building lots of different types of aircraft, they can all operate in the many different countries they have. And this is a real challenge to achieve, because we need to create a global agreement on how these concepts should work, even though they will operate in just a small urban airspace, usually in a particular city or province or urban area. In fact, actually, the standards that we use for ground infrastructure, the standards we use for information exchange and air traffic management really should be the same standards we will use in every city in Korea, but also every city around the world. So we need standards development work and we need alignment between different organizations. So we need to see the companies that work on this coming to some agreement on what is suitable. And what Eve tried to do is work with lots of air navigation service providers and regulators and other companies, other OEMs, other manufacturers, to really come up with a common concept of operations for how the air traffic management should work in the urban environment.
네, 감사합니다. 한 가지 질문 더 드리겠는데요.
Thank you so much. I'd like to ask you one more question. A recent article says that Eve has begun the process to obtain a type certification for its eVTOL with the Brazilian Aviation Authority. As far as I understand, no eVTOL has received complete design certification so far. Can you share if there is any agreed upon direction in the certification process with the authority, and when do you expect to complete the certification process?
Thank you. So there will be lots of good information about Eve's certification process delivered on our website at the appropriate time. As you said, yes, we have just recently announced the agreement with ANAC, the Brazilian regulator. We are intending to complete certification in 2025 to enable first operations with passenger carrying operations in 2026. There is some really good detailed information that can be gained from Eve's website through the links on Eve's website that show our certification pathway and the journey from here to 2026.
네, 감사합니다. 마지막으로 한 가지 질문 더 드리겠습니다.
So my final question. This is my final question. In this session, we discussed that the public-private cooperation is essential to implement UAM services. The UK Urban Air Mobility Consortium, where Eve is participating as a member, seems a great example of such cooperation. So can you tell us what the consortium is doing right now and its future plans as well?
I agree with you that a consortium like the UK consortium is a really good way to create harmonisation and agreement on the way forward. So we had involvement from the regulator, the air navigation service provider, traditional airspace users and airports, and then the new industry of UAM. The consortium which Eve put together and is leading is just concluding the work on our concept of operations. So we hope to publish our concept of operations in the next 2 months or so. From that, Eve thinks it is really important to continue to work on these concepts in the UK, and we look to work with the regulator and the air navigation service provider in the future to help enable this future industry in the UK. But we also want to take those learnings and work with other parties around the world. So build on that work in Asia Pacific, build on the work in America, Europe, and South America as well. So we look to build on this work not just in the UK, but globally with other parties and other national authorities and industry participants.
네, 답변 감사합니다. 예, 다음은 스카이포츠의 홍리후이님께 이제 질문 하나 드리겠습니다. 네, 스카이포츠사에서는 다양한 나라에서 테스트베드를 구축하거나 아니면 실제 UAM 서비스를 위한 버티포트 구축과 협력을 추진 중에 있습니다. 이제 버티포트를 구축하기 위해서 필요한 주요 핵심 요소에 대해서 조금 전에 설명을 해주셨는데요. 이제 실제 UAM 서비스를 위한 버티포트를 구축할 시에 가장 중요하게 고려해야 할 요소가 어떤 것들이 있을까요?
So the Skyports is building a testbed in various countries who are in the process of collaborating with building a vertiport for actual UAM service. You mentioned the key factors in vertiport. What is the most important factor in building vertiport for actual UAM services?
Oh, that's a very good question. So I think the first and most important that we have to settle upfront is finding vertiport sites and having a strong government that can allow us to identify the route to market. So right now, in the discussions that we have, we are working through technical requirements from authorities, whether they are planning authorities, aviation authorities, road authorities, or even environment authorities, to go through each and every one of their specifications and see how we can factor all these specifications on site. So I would say twofold for me, the most important things right now: finding the right site and finding a strong regulatory and governmental framework that we can work within. And of course, all the other factors come in as well. We have to find a good OEM partner to go into market with, such as Eve. And all these factors come into play when we go towards developing a vertiport in any country.
네, 감사합니다. 예, 질문 하나 더 드리겠습니다.
Let me ask you one additional question. So vertiport is a very complex system as the core infrastructure of UAM service. So this is actually more complicated than I expected. But unfortunately, there seems to be no internationally agreed or government regulation yet. So please share how Skyports vertiports are overcoming regulatory barriers to build the relevant infrastructure. What are your strategies?
Yeah, so we have a dedicated regulatory team within Skyports, and this team has extensive experience with all the aviation bodies and also sit on bodies such as EASA to help them with the crafting of vertiport guidelines. So we are the chair for one of the groups that will be drafting the vertiport standards. So being in deep discussion with these aviation authorities allow us to have the earliest look at how these regulations are being crafted and also have a hand in guiding the crafting of these standards. So this is a critical part of how we go about doing our design, where we can factor in the latest guidance into any of our development plans. And along the way, I would say that we are also actively trying to see how we can best adapt some of the existing guidances, whether for traditional airport or for helicopter designs into our ongoing regulatory and design framework.
네, 감사합니다.
Thank you for your answer. So I think these are the questions we have pre-selected, but I think it's time to open the floor for questions. So raise your hand if you have any questions, then our mic runners will come to you. Hello everyone, I am Jang Se-won from KIAST. I have a question to Eve.
Hello, I am Se-won from KIAST and I have a question for Rob from Eve. So I've heard that Eve is the top ranker in terms of eVTOL orders. So what do you think is the main driver for such achievement? Thank you.
So we have published 1,735 orders, which I think some people I think is the largest number of published orders. I think so. Why do I think personally that we've achieved that? I think there's a few different factors. Firstly, I think being part of Embraer is really important. So we know as Embraer how to type certify aircraft. And we have a really strong track record in doing this. We know how to build aircraft and we know how to certify aircraft. And as one of the presenters said this morning, that is not something that it is easy to do. And so I think that really has helped grow the customer group. Secondly, I think the design of our aircraft is really good. So we call it a lift plus cruise design, where we use a set of rotors that are fixed for lift and then pusher props for the cruise phase of flight using wing-based lift. The advantage of this design is that it's actually relatively simple, and that has some strong advantages in both certification and maintenance, and that translates into cost as well. So the lift plus cruise design is a very efficient design. And a very likely to be a cheaper and less costly and less complex design to certify. So I think these are a couple of the reasons, but I think another reason why we see a lot of interest in Eve is not just the vehicle, but our focus on delivering the whole industry. And really, there will be vehicles that will fly. There will be vehicles that will fly sooner than Eve's vehicle. But for a scalable industry to create the future business, to create the demand and really deliver on the future of what UAM could be, we need to think about the whole ecosystem. And Eve focuses heavily on developing the whole ecosystem, both through our partnerships, but also through our work on air traffic management. And solving the air traffic management challenge will be very critical for the real scaling and the true development of the UAM business.
예, 감사합니다. 혹시 또 현장 참석자분들 중에
Thank you so much. Are there any person from the audience who have any questions to the speakers? Thank you.
예, 안녕하십니까. SK텔레콤
So I am Sang Seok-hwan from SK Telecom.
항공우주연구원 황창.
I'd like to ask my question to Mr. Hwang Chang-jeon from KARI. Thank you for such an insightful presentation. So you are making a lot of efforts to increase speed. So I see our government institution, including MOTI and MOLIT, they are working really hard to push this project forward. So, but I do want to know whether the government organization have any more, any further interest in related projects. For example, when we are talking about safety, we need to, it takes time because the existing aerospace companies, they have a track record that goes about 100 years ago. So they have sufficiently proved their safety for their operations and services. But as for the UAM services, we are, of course, we are going through very new kind of system, and we are going through all these changes very rapidly. So to sum up, I believe I'd like to ask a government perspective about whether you see any kind of areas where you see the need to pick up more speed to further develop the UAM ecosystem and infrastructure. So as I've said, I believe the top priorities in UAT is safety.
그다음에 이제 통상의 항공기와는 다르게
And unlike existing aircrafts,
하는 부분. 왜냐하면 이제 도심에서 운영해야 돼.
we need to decrease its noise level because we will operate these UAM vehicles across the cities. And because it is flying over densely populated regions, we might face restrictions in airspace. I believe these are some of the common concerns that are discussed across the country. As experts would understand, well, EASA has recently published the special conditions, and as for the eVTOL,
10회 구송 비행 시간당 한 번 이하에
so
정해서 있는데요.
so as I've said, they have special set the goals for the special conditions by the EASA.
똑같습니다. 근데 아마 이제 또 항공의 역사를 잘 아시는 분들은 아시겠지만 뉴욕에서
In New York, using helicopters, As far as I understand, in New York, they had carried out similar services back in the 1970s using helicopters. But back then, they had a big accident. And after that big accident, they had eliminated that service completely due to the safety reasons. So that's why safety is important, and we need to take time and we need to go step by step to ensure everything is safe. So as been repeatedly mentioned, Korea will host a grand challenge on this coming Thursday. So on that event, we will give you more information to increase public acceptance and to promote safety for these UAM vehicles. Thank you. Are there any more questions from the audience?
예, 국민대학교 윤영현 교수입니다.
I am Yoon Young, professor. One of the key issues being discussed at this moment is
어떻게 해서 우리가 인증과 가망 인증이
when we develop eVTOLs, how we are going to deal with the certification. I think KAC 100 is taking a pivotal role in developing the necessary standards for certification. But eVTOL
오파우 계획 자체가 훨씬 더 범용성 있게 많이 활용될 수 있기 때문에
can be utilized much more than we can think of.
다 끝나고 새롭게 인증기로서 유사하게 한다고 그러면 어려우니까 지금 이 사업이 가고 있는 것에 같이 병행해서
Maybe we can
형식 승인 뭐 그다음에 제작 승인 그다음에 가망 인증 이렇게 딱
like the type certification and manufacturing certification. I think we need to act fast to develop certification for both eVTOLs and OPAV.
어떤 것이 제 생각.
Maybe I think we might want to create a new project for this combined effort. So this is something that I can answer. Thank you for your suggestion. Maybe the government can reflect on it. Thank you.
다른 질문 있으신가요?
Is there any other questions from the floor?
예, 다른 질문 없으시면은
If we don't have any other questions, I'd like to raise a personal question. So this question is to Eve, Dr. Rob Weaver. In Brazil, Rio de Janeiro, there has been air taxi service or air taxi hub service with UAM. Is there any other UAM service connecting different cities?
So the urban air mobility services in Sao Paulo are probably the largest air taxi market in the world. Outside of that, the connecting cities, so intercity regional air mobility, still sits more with traditional aircraft rather than helicopters. The interesting thing about the Sao Paulo air mobility industry is that the movements of the aircraft are extremely limited because of air traffic control. In fact, in certain areas, only 6 vehicles can fly at any one time because of the procedural constraints placed by air traffic control. And this is a real challenge for the industry, because if we were to apply these types of constraints for the new eVTOLs and the new UAM industry, we would not be able to scale it. So the Sao Paulo example is a good one to look at how we need to come up with new ways to manage that challenge.
네, 감사합니다. 개인적인 질문 한 개만 더 드리겠습니다.
So I'd like to ask one more question. This question goes to Miss Hong-Lee Hui from Skyport. Regarding vertiport from physically, we promptly think about a building, maybe a vertiport on rooftop of the building. But when we are actually building such kind of vertiports, special construction knowledge and expertise would be needed. And today we have aerospace experts with us here. But I believe Skyport is involved in vertiport, this kind of vertiport services. So, amongst your employees and staff, how much percentage of your employee are construction specialists and experts?
So, in terms of specialty, a good percentage of our technical team come from product engineering and from airport planning backgrounds. And myself, I come from a urban planning background, having been part of the Urban Redevelopment Authority and the JDC Corporation in Singapore. So I would say that in terms of actual construction, that we work very closely with partners such as in the past Mott MacDonald to come up with the actual detailed engineering of any site. But the vertiport planning, vertiport design, and operations will come from Skyports.
예, 답변 감사합니다.
Thank you for your answer.
네, 오늘 질문 남겨주신 분들과 이제 답변해주신
For those who posted your comments and the speakers who gladly answered the questions, thank you very much. So I could see everyone involved in this event had a great interest in the UAS and its future. So this is Dr. I'm sorry. Thank you for your participation, and please welcome. Please give them a big round of applause. And we had a lot of questions for Eve and Skyports. I hope we could have more opportunities like this to exchange ideas and insights. So I think it's time to wrap up. Thank you everyone for having us today. Thank you.